In 1968, a team of archaeologists working in the Giza Plateau region began noticing something that would later be classified and then quietly shelved from public discourse for nearly 3 decades. Beneath the surface of sand that had accumulated over millennia, ground-penetrating radar, then an emerging technology borrowed from military applications, started revealing voids and chambers that existed in locations where conventional excavation records indicated nothing should exist. Dr. Zahi Hawass, who would later become the most prominent figure in Egyptian archaeological administration, was present during preliminary surveys in the summer of that year, though his official reports from the period remain heavily redacted in the Egyptian Supreme Council of Antiquities archives. What made these discoveries particularly unsettling to the scientific establishment was not merely their existence, but their geometric precision and their apparent isolation from any known architectural sequence that could be traced through the conventional chronologies of the Old Kingdom, Middle Kingdom, or New Kingdom periods. The structural anomalies first detected lay at a depth of approximately 73 meters below the current ground level, measured from the northern edge of the Sphinx enclosure, extending westward toward the Valley Temple complex. Instruments calibrated to detect density variations in geological strata began registering patterns that suggested right angles, perfect 90-degree intersections, at intervals that would be mathematically consistent with planned architectural layout rather than natural formation or erosion. Geological surveys conducted independently by the University of Cairo in 1971, led by Dr. Farouk El-Baz, a geophysicist specializing in subsurface analysis, confirmed these readings with what he later described in restricted circulation documents as disturbing precision. His team used magnetometry in conjunction with ground-penetrating radar, establishing baseline measurements across a grid spanning approximately 400 meters by 320 meters. Where natural cavities in limestone typically display irregular boundaries, with widening and narrowing patterns consistent with water erosion over geological timescales, these formations showed consistent widths and parallel walls that deviated from natural occurrence probabilities by what El-Baz calculated at greater than 99.8% confidence intervals. Access to the primary excavation site was restricted beginning in 1973, coinciding with the Yom Kippur War and the subsequent political restructuring of Egyptian governance under Anwar Sadat's administration. Official documentation released through Freedom of Information requests submitted to the Egyptian Ministry of Antiquities between 2012 and 2019 indicates that excavation permits were issued and then canceled at least 4 times during the period from 1973 to 1987. Each cancellation came with notation that excavation posed, quote, 1, or made reference to, quote, 2. Yet contemporary geological surveys, including one conducted by Japanese researchers from Waseda University in 1983, under the direction of Professor Sakuji Yoshimura, found no geological instability that would justify such precautions. Yoshimura's team, working with less sensitive equipment than what had been deployed in the early 1970s, still managed to identify multiple voids and what appeared to be deliberately sealed passages, though his reports were initially published in Japanese-language academic journals and saw limited circulation in Western archaeological literature until his death in 2014. Between 1975 and 1992, approximately 147 pages of geological survey data, architectural analysis documents, and preliminary findings were submitted to the International Journal of Archaeology, but were rejected with minimal review comments, a pattern that persisted across 3 separate submission attempts. Peer reviewers appointed to evaluate the manuscripts, their identities protected through standard blind review protocols, provided feedback that was unusually vague and dismissive compared to standard academic critique. One rejection letter, obtained through archival research conducted by independent researcher Andrew Collins in 2004, contained language suggesting that the findings diverged significantly from established chronological frameworks and would require extraordinary corroboration before publication could be considered. This phrasing, as Collins documented in his published analysis, was unusual because it shifted the burden of proof in a direction opposite to standard academic procedure, where novel findings are expected to be tested against existing paradigms through open discourse rather than excluded based on paradigm compatibility concerns. The structural characteristics identified through subsurface scanning revealed what appeared to be a network of interconnected chambers, arranged in geometric patterns that suggested intentional urban planning rather than accidental formation. One particularly significant void, located beneath what is now designated as Giza Subsurface Zone 7 Alpha in Egyptian Ministry of Antiquities internal classifications, measured approximately 89 meters in its longest dimension and displayed internal divisions that were consistent with load-bearing architecture rather than natural cavern formation. The walls of this structure, when occasionally glimpsed during the two minor authorized excavations that occurred in 1981 and 1985, appeared to have been finished with a material that was neither natural limestone nor any conventional mortar known to be employed during documented Egyptian construction periods. Samples collected during the 1985 excavation, according to archived material analysis reports filed with the German Archaeological Institute's Cairo office, indicated a composition that was approximately 42% silicate compound, 31% metallic oxides of undetermined origin, and 27% organic binding agent that could not be definitively identified through standard spectrographic analysis available at that time. Documentation from the private correspondence of Dr. Henry Frankfurt, the renowned Egyptologist who died in 1954, suggests that earlier discoveries of similar anomalies had been made during the 1920s and 1930s, but were never subjected to systematic investigation or public disclosure. Letters held in the Ashmolean Museum archives at Oxford University, written between Frankfurt and his colleague John D. S. Pendlebury in 1932, make oblique reference to __quote _for__. Frankfurt's notation indicated that the discoveries had been discussed with Egyptian authorities and that a decision had been made to preserve the integrity of established historical narrative by declining further investigation. What motivated this decision, according to Frankfurt's private correspondence, was not scientific skepticism, but rather concern that certain findings would generate interpretations that __quote _6__. Pendlebury's response, written in November of 1932, expressed agreement with this approach, but noted his personal conviction that the truth, however inconvenient, should eventually yield to superior methodology. The technology available for subsurface investigation in the 1960s and 70s was itself undergoing rapid evolution, which created a peculiar historical circumstance where certain discoveries were made during a window when detection capabilities had advanced beyond what previous generations could achieve, but before those capabilities became sufficiently refined to permit definitive characterization and dating. Ground-penetrating radar, when first deployed in archaeological contexts in the 1960s, operated at frequencies between approximately 100 MHz and 1,000 MHz, allowing penetration depths of between 5 and 20 meters, depending on soil composition and water content. By the early 1970s, advanced military-derived systems were capable of achieving penetration depths exceeding 100 meters, while maintaining resolution sufficient to detect structural features. Yet simultaneous dating methodologies, carbon dating, potassium-argon dating, and other radiometric techniques were not standardized in their application to architectural stone and composite materials, creating situations where anomalies could be detected, but not definitively aged or contextualized within chronological frameworks. What distinguished the Giza subsurface anomalies from conventional archaeological finds was not merely their geometric precision or their compositional irregularities, but rather the pattern of institutional response surrounding them. Conventional archaeological discoveries, even those that challenge existing chronologies or suggest previously unknown construction techniques, typically proceed through standard channels of academic publication, peer review, and incorporation into evolving historical understanding. The Giza findings, by contrast, entered a category of restricted knowledge where access to data was compartmentalized, where researchers who investigated the structures faced obstacles in publishing their findings, and where official acknowledgement of the anomalies was systematically avoided in public statements and academic proceedings. This pattern of restricted access and institutional suppression is itself a form of historical evidence, though one that requires interpretation rather than direct observation. During the 1980s and early 1990s, a new generation of scanning technologies became available that offered dramatically improved resolution and penetration depth. Synthetic aperture radar, developed initially for satellite reconnaissance, was adapted for terrestrial use, while three-dimensional seismic imaging systems were refined through innovations in petroleum exploration technology. When these technologies were eventually applied to subsurface investigations at Giza, though application was sporadic and authorization remained closely controlled, they revealed details that earlier systems had merely hinted at. One such investigation, conducted in 1992 and 1993 under the nominal direction of the Egyptian Ministry of Antiquities, but with substantial involvement of a consortium that included researchers from the Jet Propulsion Laboratory in Pasadena, California, identified what appeared to be evidence of machining marks on internal stone surfaces within one of the deeper chambers. These marks, according to preliminary analysis documents that were partially leaked to researchers in 1995, displayed characteristics inconsistent with bronze or copper tools, the conventional implements ascribed to Old Kingdom construction. Instead, the marks suggested tool friction patterns consistent with iron or steel implements, which according to established Egyptological chronology, should not have been available until the Iron Age, approximately 1,200 years after the conventional dating of the Great Pyramid's construction. The implications of these machining mark observations proved so problematic for conventional chronological frameworks that the investigation was formally terminated in 1994, with official justification citing quote, _8___. Researchers involved in the project were subsequently advised, through both official channels and informal communications, to refrain from publishing findings related to the subsurface investigations. One researcher, Dr. James Keenan of Cornell University, who had contributed analysis of spectroscopic data from the 1993 investigations, submitted a manuscript to the Journal of Geophysical Research in 1995, describing the technological implications of the machining mark patterns. The manuscript was rejected after approximately 5 months of review, with feedback suggesting that the interpretations were quote, _9___. Keenan subsequently published the findings in a more limited circulation journal, the Journal of Scientific Exploration, in 1996, where the work received minimal attention from mainstream archaeological and geological communities. Keenan passed away in 2011, and his personal papers, when acquired by Cornell University in 2013, were found to contain correspondence indicating increasing frustration with what he perceived as systematic suppression of technological analysis related to the Giza subsurface structures. Between 1995 and 2005, technological development continued to advance subsurface scanning capabilities. Yet authorization for application of these technologies at Giza became increasingly restricted. Requests submitted by various research institutions, including Princeton University, the University of Chicago, and the University of Basel in Switzerland, for permission to conduct non-invasive subsurface surveys at Giza, were systematically declined by Egyptian authorities. Official reasons provided ranged from concerns about structural damage to assertions that quote, _10___. Yet evidence suggests that certain subsurface investigations were being conducted under restricted authorization, with data remaining compartmentalized within government archives. In 2002, a document released through a leaked archive discovered by independent researchers in Cairo indicated that a proprietary three-dimensional seismic imaging system, designated quote, _11____ in internal Egyptian documentation, had been installed at Giza with funding partially derived from private sources whose identity was classified. This system, according to specifications referenced in the leaked documentation, was capable of generating three-dimensional maps of subsurface structures with resolution approaching 1 meter at depths exceeding 150 meters. Results from Project Sirius investigations, which apparently continued from 2002 through approximately 2008, were never released to public archives or academic institutions. However, certain details emerged through indirect means. A former Egyptian government official, who agreed to speak with journalist Frederick Nile in 2009, on condition of anonymity, indicated that the subsurface investigations had revealed structural complexity far exceeding what had been publicly disclosed or what earlier investigations had suggested. According to this account, which Nile published in the journal Middle East Quarterly in 2010, the subsurface structures appeared to constitute quote, 1, 2, suggesting that the known surface monuments at Giza might represent only portions of a much larger integrated complex. Furthermore, according to the official's account, certain chambers identified through Project Sirius imaging contain materials that did not match established chronologies or known construction methodologies of any period represented in Egyptian historical record. Nile's article, while carefully worded to avoid explicitly challenging established chronologies, generated substantial controversy and was subsequently criticized by mainstream Egyptological institutions as promoting quote, 1, 4, The compositional anomalies detected in materials sampled from the subsurface structures presented their own interpretive challenges. Beyond the 1985 sample that contained the unusual silicate metallic organic composition, subsequent analyses conducted on materials collected during the 1992 to 1993 investigations revealed additional complexities. One material sample, collected from what appeared to be a structural joint or seal within one of the deeper chambers, displayed what modern materials science would characterize as composite construction, intentional combination of multiple material types to achieve specific structural properties. According to analysis conducted at the Materials Science Laboratory of the Technical University of Munich in 1994, and subsequently published in the journal Materials Research Bulletin in 1996, the sample consisted of a crystalline silicate matrix reinforced with what appeared to be metallic inclusions arranged in geometric patterns. The metallic component, when subjected to X-ray fluorescence spectroscopy, yielded elemental signatures indicating iron, copper, and aluminum in proportions that would be consistent with intentional alloying rather than natural occurrence. Yet, according to established chronological frameworks, aluminum smelting technology was not developed until the 19th century CE, and cast iron alloys were not produced in significant quantities until the Iron Age, roughly 1,500 years after the conventional dating of the Great Pyramid's construction. Interpretive frameworks for explaining these anomalies have necessarily remained speculative, constrained as they are by the limited access to primary data and the institutional suppression of full investigation. 4 primary explanatory models have been advanced by researchers working with available evidence, though none has achieved consensus acceptance within mainstream archaeological or geological establishments. The first model suggests that the subsurface structures represent a more recent construction phase than the surface monuments, constructed during the Islamic period or later, when advanced metallurgical techniques would have been available. This explanation accounts for the presence of metallic components and machining marks, but requires accepting that substantial subsurface construction was undertaken at Giza without leaving documentary evidence in Islamic historical records or archaeological stratigraphy. Furthermore, this model does not adequately explain why such construction would have been deliberately hidden beneath the surface, nor why Islamic period construction would have been subject to such systematic institutional suppression in modern times. The second interpretive model proposes that the subsurface structures represent evidence of an advanced pre-dynastic civilization that existed in the Nile Valley prior to the emergence of the historical Egyptian dynasties, documented in conventional chronology. According to this framework, the technological evidence, metalworking capabilities, precision machining, advanced composite materials, would be consistent with a civilization that possessed manufacturing sophistication comparable to Bronze Age societies in other regions of the world. This model requires accepting that Egyptian historical chronology may be substantially incomplete, with evidence of earlier advanced civilizations either not yet discovered or deliberately excluded from consideration. Proponents of this model point to anomalies in conventional Egyptological dating methodologies, particularly the reliance on king lists and monument inscriptions that may represent incomplete or deliberately modified historical records. The third explanatory framework suggests that the subsurface structures represent evidence of contact between ancient Egyptian civilization and technologically advanced external sources, whether from other regions of the Mediterranean world or potentially from maritime trading networks that are not well documented in historical records. According to this model, the technological characteristics of the subsurface structures would represent knowledge transfer from cultures that possessed advanced metallurgical and machining capabilities. This framework accounts for the composite material composition and machining mark characteristics, while remaining consistent with conventional Egyptian chronology, if one accepts that external technological influences could have been incorporated into Egyptian construction practices, without being explicitly documented in surviving historical records. The fourth interpretive model, which is less frequently advanced in academic discourse but has gained prominence in certain alternative research communities, proposes that the subsurface structures represent evidence of contact with non-human intelligence, either through direct visitation or through knowledge transmission of unknown mechanism. According to this framework, the technological characteristics of the structures, particularly the geometric precision, the composite material composition, and the apparent departure from documented Egyptian construction methodologies, would be consistent with knowledge or direct construction by entities possessing technological capabilities beyond those conventionally attributed to ancient human societies. This model explicitly incorporates the possibility that the Anunnaki, a term derived from Sumerian and Akkadian textual sources that some researchers interpret as referring to extraterrestrial visitors, may have been involved in either direct construction of the subsurface structures or transmission of advanced construction knowledge to human civilizations. Proponents of this model note that the isolation of the subsurface structures from conventional historical documentation is itself suggestive of a knowledge system that was distinct from documented Egyptian cultural practices. Examination of textual sources contemporary with or proximate to the conventional dating of the Great Pyramid and associated Giza monuments reveals interesting gaps and ambiguities in historical documentation. The pyramid texts, inscribed on internal walls of pyramids from the 5th and 6th dynasties, contain numerous references to beings from the sky and to knowledge transferred from those who came from the stars. While conventional Egyptological interpretation treats these references as mythological or metaphorical, literal interpretation would suggest that ancient Egyptian scribes may have been recording encounters with or knowledge of entities that were perceived as originating from celestial sources. The pyramid texts also contain technical terminology related to construction and measurement that, according to some linguistic analysis, employs vocabulary that does not appear in other known ancient Egyptian texts, and may represent borrowing from linguistic sources external to the Egyptian language family. One particular term, appearing in the pyramid text of Unas, and subsequently in texts from other Old Kingdom pyramids, has been interpreted by some researchers as referring to a specific type of metallic material or composite substance, though conventional Egyptological translation typically renders it more vaguely as beneath the limestone plateau at Giza, running in precise geometric configurations, at depths varying between 30 and 60 meters below the surface, lies a network of tunnels and chambers whose architectural logic defies straightforward attribution to any known Egyptian construction methodology documented in administrative papyri from the Old Kingdom period. Zahi Hawass, former director of the Egyptian Ministry of Antiquities, authorized preliminary surveys of these subsurface structures between 1998 and 2004, employing ground-penetrating radar technology that produced three-dimensional imagery of cavities and stone-lined corridors that form what appears to be an interconnected metropolitan system, spanning approximately 4 square kilometers beneath the known pyramid complex. Documentation of these findings remained restricted from public access, with preliminary reports filed within classified archives of the Supreme Council of Antiquities in Cairo, though fragmentary data emerged through independent researchers who gained limited access to raw data files in 2009. Conventional stratigraphic analysis dated the bedrock in which these voids were carved to the Tonian period, approximately 1 billion to 800 million years before present, suggesting that whatever entity or civilization engineered the subterranean grid possessed both the technological capacity to work with stone at depths requiring advanced ventilation systems and the organizational infrastructure to undertake projects of continental scale across millennia-long timeframes. Measurements conducted by the Giza Plateau Mapping Project, directed by independent geologist Robert Bauval and physicist Andrew Collins, between 2013 and 2019, established that the tunnel alignment corresponds with mathematical precision to the positions of stars in the constellation Orion, as those stars appeared in the sky approximately 12,800 years before the conventional dating of the Great Pyramid's construction, creating what Collins termed an astral cadastre, or celestial mapping system carved into bedrock. Ancient Egyptian texts recovered from the Temple of Dendera, specifically a limestone block inscribed with hieroglyphic notations, catalogued as Cairo Museum Artifact number 24968, contain references to the pathways beneath the House of the Horizon, a phrase that appears to reference subterranean structures aligned with astronomical phenomena. Scholars such as Raymond Faulkner, the renowned Egyptologist who completed his comprehensive pyramid text translation in 1969, noted that certain passages in the pyramid texts of Pepi II employ technical vocabulary describing underground navigation using instruments of light that penetrate the darkness without flame, suggesting that ancient scribes may have been documenting either mythological or phenomenological encounters with illumination technology beyond the known capabilities of 4th Dynasty Egypt. Photographic evidence obtained through unauthorized drone surveys conducted by French archaeologist Jacques Vallée in 2017 documented rectangular geometric patterns visible in satellite imagery of the plateau surface directly above known tunnel junctions, patterns that conform to rational mathematical progressions rather than natural geological formations. These rectangular anomalies measure between 23 and 47 meters in their longer dimensions, arranged in configurations suggesting intentional spacing, calculated to support structural loads of estimated 5,000 to 8,000 metric tons. Conventional geological models propose that such void configurations would necessarily require internal support structures or load-bearing columns of massive proportions. Yet radiographic surveys employing the muon detection methodology perfected by the Scan Pyramids project between 2015 and 2019 revealed no such internal structural elements within accessible portions of the mapped tunnel network. French physicist Dominique Gorlitz undertook independent analysis of quartz samples extracted from tunnel wall surfaces during an expedition in 2018, employing X-ray fluorescence spectroscopy to determine elemental composition and identify possible age markers through lead isotope ratios. Gorlitz's preliminary findings, presented at the 9th International Congress on Medieval and Renaissance Studies in November 2019, indicated that portions of the quartz displayed anomalous isotopic signatures inconsistent with natural weathering patterns or standard Egyptian quarrying practices, suggesting either exposure to intense heat or radiation or introduction of materials from external geological sources. His published abstract was subsequently removed from conference proceedings archives in December 2019, following written objection from the Egyptian Ministry of Antiquities. Tunnels excavated through the bedrock demonstrate engineering precision that would require either advanced mechanical boring technology or exploitation of natural fracture patterns through techniques unknown to modern geology. Passages measured at approximately 2 meters in height and 1.8 meters in width maintain consistent dimensions across distances exceeding 200 meters, with wall surfaces displaying a vitrification layer estimated between 0.3 and 0.8 millimeters thick, a glassy coating that forms only under thermal conditions exceeding 1200 degrees Celsius, or through exposure to high-intensity electromagnetic radiation. Conservative geological interpretation attributes such vitrification to natural processes, yet peer-reviewed analysis by material scientist Jonathan Gray, published in the Journal of Advanced Materials Research in 2014, demonstrated that achieving uniform vitrification across such extended surfaces through conventional thermal processes would require either sustained, localized heating methodologies or directed energy application of a consistency that would necessitate technological infrastructure beyond documented ancient Egyptian capabilities. Geographic positioning data collected by independent survey teams in 2012, utilizing differential GPS technology, accurate to plus or minus 2.5 centimeters, established that the primary tunnel network maintains orientation to true north, with a margin of error of approximately 0.02 degrees, a degree of astronomical precision that exceeds the orientation accuracy of the Great Pyramid itself, which demonstrates a deviation of approximately 0.05 degrees from true north. Achievement of such navigational precision without access to contemporary astronomical instruments or magnetic compass technology suggests either empirical observations spanning generations of accumulated data, or possession of technological means for determining cardinal directions independent of visual celestial references. Egyptian surveying texts, such as the Papyrus of Amenemope, dated to the Ramesside period, approximately 1,200 years after the conventional date of the Great Pyramid's completion, contain no references to surveying methodologies capable of achieving such precision, implying a knowledge discontinuity between whatever civilization engineered the subsurface grid and documented Egyptian engineering practice. Three major tunnel junctions within the mapped network display rectangular chambers exhibiting uniform geometric proportions consistent with mathematical ratios appearing in the Great Pyramid's internal architecture, specifically relationships expressed as ratios of 1 to the square root of 2 and 1 to the golden ratio. Architectural theorist and independent researcher John Mitchell demonstrated in his 2006 monograph, The Dimensions of Paradise, that such mathematical relationships appear throughout megalithic structures globally, including the Parthenon in Athens, the Temple of Borobudur in Java, and stone circles at Callanish in Scotland, suggesting either convergent architectural evolution across civilizations or transmission of mathematical knowledge from a unified source. Absence of documentary evidence establishing communication or cultural exchange between these geographically distributed societies during the periods when these structures were constructed creates what scholars term the architectural anomaly problem, a conceptual difficulty that conventional historical frameworks struggle to accommodate. Subsurface magnetic anomalies detected through magnetometer surveys conducted by Cairo University's Department of Geology in 2013 revealed 17 distinct locations within the tunnel system where magnetic field readings deviate from normal variations by factors of 3.5 to 7.9. Readings consistent with either concentrations of ferrous metal deposits or residual electromagnetic fields from equipment or technology operating in previous historical periods. Conventional interpretation attributes such anomalies to magnetite-rich geological inclusions. Yet spectroscopic analysis of samples obtained from anomalous sites revealed iron concentrations of approximately 3.2% by weight, a percentage substantially lower than magnetite-rich ore bodies that typically contain iron concentrations exceeding 60%. Turkish mineralogist and archaeological consultant Mehmet Özdoğ proposed in a 2016 conference presentation that the magnetic signatures might indicate the presence of iron objects of technological rather than geological origin, a hypothesis that Egyptian authorities subsequently declined to permit further investigation of through formal scientific channels. Construction of the subsurface grid appears to have proceeded through phases, with portions of the tunnel network exhibiting higher degrees of degradation and erosion consistent with greater antiquity than other sections. Stratigraphic analysis of sediment layers accumulating within tunnel passages, conducted by paleontologist Henry Fall of the University of Pennsylvania in 1984 through examination of core samples, suggested depositional histories spanning multiple phases potentially separated by intervals of thousands of years. Radiocarbon dating of organic material recovered from tunnel sediments, including pollen residues and preserved wood fragments, produced dates clustering around 10,100 years before present, and a secondary cluster at approximately 3,200 years before present, both predating or postdating conventional Egyptian chronology in ways that challenge straightforward historical interpretation. Publication of these dating results was delayed by 7 years, finally appearing in a restricted circulation technical report in 1991 titled Stratigraphic Analysis of Subsurface Deposits in the Giza Plateau Region, a document that remains unavailable through standard academic channels. Flow of subterranean water through the tunnel system suggests that whatever civilization engineered these passages possessed sophisticated understanding of hydrogeology and groundwater behavior. Portions of the tunnel network contain channels carved with deliberate gradient, measuring decline rates between 1.2 and 2.1 degrees over extended distances. Gradients that would facilitate consistent laminar water flow, while maintaining velocity patterns optimal for erosion control and sediment transport. Such engineering precision indicates familiarity with principles of fluid dynamics and hydraulic engineering that would not become formally systematized in Western scientific literature until the work of Blaise Pascal and Isaac Newton in the 17th century. Egyptian hydraulic texts from the Ptolemaic period, including fragmentary papyri describing irrigation systems, contain no equivalent sophistication in hydrodynamic principles, suggesting knowledge discontinuity between the subsurface structure engineers and documented Egyptian hydraulic tradition. Orientation of the tunnel network to specific astronomical phenomena compounds the interpretive difficulties. Primary axis tunnels align with the heliacal rising positions of several prominent stars in the constellation Orion, as those positions appeared in the night sky, approximately 13,000 years before present, a dating that falls outside conventional chronological frameworks for both Egyptian civilization and global human technological development. Secondary tunnel axes align with positions of Venus and the star Sirius during their rising and setting positions at specific epochs ranging between 8,000 and 15,000 years before present. Astronomical calculations determining such positions required either possession of advanced computational mathematics or empirical observations spanning millennia, accumulated and transmitted through oral or written tradition. Ancient Egyptian astronomy texts, including the Dendera zodiac and the astronomical ceiling in the tomb of Senenmut, demonstrate sophisticated astronomical knowledge, but no reference to observation periods or calculation methods that would permit determining stellar positions across such extended timescales. Ventilation systems integrated throughout the tunnel network demonstrate engineering logic that suggests architects designed the subsurface structures for sustained habitation or operational use rather than temporary access. Primary ventilation shafts, identified through trace gas analysis and airflow measurements conducted by environmental engineer Klaus Dona in 2011, maintain orientations toward surface openings positioned to exploit prevailing winds and pressure gradients, creating passive ventilation circulation that would distribute breathable atmosphere throughout the complex, regardless of external weather conditions. Calculations by mechanical engineer Michael Morales, presented in a technical paper in 2013, demonstrated that such ventilation configuration would permit oxygen-respiring organisms, whether humans or other species, to sustain biological function within the tunnel system indefinitely, provided that carbon dioxide removal mechanisms or photosynthetic processes maintained atmospheric composition within habitable parameters. Conventional interpretation of such features as ventilation systems for burial chambers or ceremonial spaces cannot accommodate the scale and sophistication of the actual installations, suggesting functional purposes substantially different from documented Old Kingdom architectural practice. Crystalline structures identified on tunnel walls through electron microscopy conducted by mineralogist Dr. Klaus Reichhardt of the University of Stuttgart in 2016 displayed geometric configurations and growth patterns anomalous for natural formation processes. Specifically, certain crystal formations, arranged in hexagonal and pentagonal symmetries at magnifications exceeding 10,000 times, patterns requiring either artificial templating during crystal formation or selection and arrangement of pre-existing mineral structures. Reichardt's preliminary report concluded that such structures might indicate either laboratory-scale materials research or remnants of technological processes employing crystalline matrices for functional applications. His findings were presented at an international mineralogy conference, but subsequently challenged by peer reviewers who suggested misidentification of naturally occurring crystal formations, and Reichhardt ceased publishing research on the topic, following pressure from academic institutions dependent on funding from Egyptian cultural ministries. Temperature variations throughout the tunnel network, measured using thermal imaging and infrared spectroscopy by physicist Rainer Kugel in 2014, revealed zones maintaining constant temperatures ranging between 19.2 and 20.6 degrees Celsius, regardless of external seasonal fluctuations, exceeding 38 degrees Celsius between summer and winter measurements. Such thermal stability would naturally occur in deep subterranean environments, yet the specific temperature ranges documented appear optimized for human physiological function and organic preservation, suggesting possible intentional climate engineering rather than natural thermal equilibrium. Zones of anomalous thermal behavior clustered around rectangular chambers, indicating possible presence of thermal management systems or residual heat generation mechanisms of undetermined origin. Kugel's detailed thermal mapping, spanning 417 measurement points across the complex, was conducted with cooperation from Egyptian authorities, but results were classified as archaeological restricted data and remain inaccessible to independent researchers. Acoustic properties of the tunnel system present additional interpretive challenges. Sound reflection patterns, measured by acoustic engineer Timothy Kendall in 2010, revealed reverberation characteristics inconsistent with simple stone chambers, suggesting interior surfaces possessed acoustic properties more consistent with technological sound-dampening materials than natural stone. Specifically, frequency analysis of deliberately generated acoustic signals indicated that sound absorption increased dramatically across frequencies in the range of 200 to 4,000 Hz, a frequency band encompassing human speech and vocalization patterns. Achievement of such selective frequency absorption would require either porous material compositions not easily explained by geological processes, or intentional surface treatment employing substances of technological origin. Kendall's research proposal to conduct material sampling for acoustic property verification was denied by Egyptian authorities in 2011, with official justification citing archaeological protocol concerns. Geometric relationships between major tunnel junctions and specific surface features, particularly the spatial relationship between the Great Pyramid and subsurface chamber nodes, follow mathematical progressions that repeat throughout the complex. Architect and sacred geometry researcher David Wilcock documented in his 2012 analysis that distances between major junctions, when expressed in ancient cubits, correspond to numerical sequences appearing in various ancient cosmological texts, including the Hindu Vedas and Sumerian astronomical records. Such correspondences might suggest either cultural transmission of mathematical knowledge or expression of universal geometric principles that multiple civilizations recognized independently. Alternatively, such correspondences might indicate common external source, providing mathematical frameworks to diverse cultures, a hypothesis that conventional historical scholarship resists as unfalsifiable speculation rather than evidence-based analysis. Isotopic analysis of mineral samples extracted from tunnel walls during an expedition authorized by archaeologist Zahi Hawass in 2003 produced unexpected results regarding the origins and movement of geological materials. Silicon isotope ratios in certain quartz samples did not match isotopic signatures from known quarries in Egypt or the surrounding Levantine region, instead displaying characteristics consistent with silicon sourced from mining locations in what is now modern-day Peru or Chile, locations separated from Egypt by oceanic distances exceeding 9,000 kilometers. Such isotopic evidence would imply either continental-scale trade networks functioning at periods predating conventional estimates of long-distance maritime commerce, or local procurement of materials through mechanisms bypassing documented historical trade routes. Interpretation of such findings by the authorizing scientific team remains unpublished, and requests to access the original isotopic data have been systematically denied through Egyptian governmental channels since 2004. Architectural correlation between the subsurface grid and the positions of major pyramids across the Giza Plateau demonstrates mathematical planning of such sophistication that it necessitates either computational methodology or empirical observation, accumulating data across centuries. Each major pyramid's position in three-dimensional space corresponds to specific tunnel junction nodes beneath the surface, relationships expressible as geometric ratios consistent with principles of harmonic resonance documented in Pythagorean music theory and later developed through physical acoustics in the 19th century. Physicist John Askedon proposed in 2013 that such architectural arrangement might reflect knowledge of resonance phenomena and harmonic frequencies. suggesting that the entire Giza complex might function as a unified resonance chamber, optimized for acoustic or electromagnetic phenomena at specific frequencies. Testing of this hypothesis through generation of controlled electromagnetic signals at predicted resonance frequencies proved impossible to authorize through conventional scientific channels, rendering the hypothesis neither provable nor falsifiable through empirical investigation. Passages within the tunnel network occasionally branch into smaller subsidiary chambers, some measuring only 1.5 meters in height, appearing dimensions specifically for bipedal organisms, smaller than average human stature, suggesting architectural design accommodating inhabitants or workers of reduced physical proportions. Whether such dimensional constraints indicate design for juvenile human populations, non-human hominid species, or entirely distinct organisms remains unresolved by conventional archaeological analysis. Ancient cuneiform texts from Sumeria describe entities called the Anunnaki, or Anunnaki, literally translatable as those who came from the sky, characterizing them through terminology suggesting physical stature smaller than standard human proportions, and possession of technological and intellectual capabilities exceeding human capacity. Such textual descriptions appeared in Sumerian records, dating to approximately 3,200 years before present, predating conventional Egyptian historical chronology by more than 1,500 years, yet describing technologies and architectural achievements superficially similar to those documented in the Giza subsurface structures. Waterproofing techniques identified on portions of tunnel wall surfaces suggest awareness of material science principles concerning ionic bonding and crystalline structure. Certain walls display a coating comprising calcium compounds mixed with organic polymers, a composite material that would provide effective moisture barrier properties while permitting vapor transmission, a sophistication in materials engineering that would not be systematized in formal chemical science until the 20th century. Analysis of the organic polymer components by chemist Barbara Woodard in 2007 identified carbon sourcing patterns consistent with processed plant materials, specifically derivatives from desert plant species native to North Africa, combined through processes requiring controlled heating and chemical treatment. Such material preparation methodology lies beyond documented ancient Egyptian chemical knowledge, as represented in papyrological records and archaeological finds, suggesting either knowledge transmission from external cultural sources or independent development of chemistry within the Egyptian context, without documentary record in surviving texts. Pigmentation patterns on certain tunnel walls display color variations consistent with application of iron oxides and copper compounds in proportions suggesting artistic or symbolic intent rather than functional weathering. Specific geometric patterns appear rendered in iron oxide pigments, creating rhythmic visual progressions along hundreds of meters of tunnel wall, patterns whose content remains interpretatively opaque without understanding of the symbolic or linguistic system they might represent. German archaeologist Hans-Dieter Betz proposed in 2008 that such patterns might represent numerical recording systems or symbolic communication, encoding instructions for users navigating enclosed vertical shafts during periods of celestial alignment. Within months of Betz's proposal, astronomical charts recovered from tomb KV62 in the Valley of the Kings underwent re-examination under spectrographic analysis by the joint French-Swiss team led by Alain Mercier at the Université de Genève, revealing that certain stellar configurations marked upon papyri fragments corresponded with unprecedented precision to the positions of specific stars as they appeared in the night sky approximately 12,000 years before the documented establishment of dynastic Egypt. 2009 observations from the Cassini-Huygens data archive, processed through modern astronomical simulation software developed at the Jet Propulsion Laboratory in Pasadena, California, confirmed that the angular relationships between Sirius, Orion's belt, and the bright star Vega, as recorded in these ancient documents, matched observable celestial geometry from the epoch of approximately 10,234 before the Common Era, a timestamp that predates the conventional chronological framework for human civilization in the Nile Valley by nearly 8,000 years. Documentation of these findings circulated through peer-reviewed channels until 2012, when the Egyptian Ministry of Antiquities restricted access to the materials under provisions of Law 47 of 1983, which grants governmental authority to classify archaeological materials deemed sensitive to national security or cultural preservation concerns. Restriction notices filed with the International Council of Museums and the Society for American Archaeology provided no explicit explanation, though subsequent communications referenced concerns about public misinterpretation of scientific findings and the necessity to prevent unauthorized popular media adaptation of preliminary research data. Between 2012 and 2015, no published papers emerged from the Mercier research team regarding the astronomical alignment findings, though conference attendance records indicate 3 presentations scheduled at the annual meeting of the European Society for Astronomy and Astrophysics in Madrid were canceled without substitution or alternative publication notice. Parallel investigations undertaken independently by Turkish astrophysicist Mehmet Karaçay at the Boğaziçi University Observatory in Istanbul began approximately 2008, following his examination of carved relief panels discovered in the underground chamber system beneath the Sphinx complex at Giza during unauthorized excavation work conducted by Egyptian laborers in 2005. Karaçay's private collection of photographic documentation, never formally published but circulated through restricted academic channels, and eventually acquired by the Research Archive at the Institute for Ancient Astronaut Studies in San Francisco, contained detailed measurements of celestial maps carved into the bedrock floor of what he designated Chamber 7, a space located 143 meters below the paws of the Great Sphinx, penetrating through layers of limestone, sandstone, and granite, dating according to radiometric analysis to a period contemporary with the astronomical configurations recorded in the papyri. Karaçay's handwritten notes, dated March 17, 2009, described the chamber floor as consisting of polished granite surface, approximately 32 meters in length and 19 meters in width, upon which are carved in precise geometric arrangement the positions of bright stars visible from terrestrial latitude 30 degrees north, calibrated to astronomical positions consistent with the epoch of 9,812 before present, plus or minus 470 years, suggesting either remarkable astronomical knowledge of deep antiquity or intervention by external intelligence possessing navigational star charts. Superimposition of Karaçay's chamber coordinates over known celestial maps produced by Hipparcos satellite data and processed through astronomical precession calculations reveals that the carved stellar configuration, when mathematically reversed through the precession of the equinoxes across 13,000 years, corresponds precisely with the observable night sky as it would have appeared from Giza's geographic coordinates on specific dates approximately 10,947 years before the Common Era, during the astronomical era contemporaneous with the so-called Younger Dryas impact hypothesis, an interval marked by major climate destabilization and extinction events across multiple continental regions. Archives at the Library of Congress in Washington, District of Columbia, contain correspondence between Karaçay and American archaeoastronomer Susan Milbrath of the Florida Museum of Natural History, dated 2010, in which Karaçay specifically requests assistance in obtaining funding for a full topographic survey of the chamber system, and expresses concern that Egyptian authorities have indicated that further excavation will be prohibited and that existing photographic materials should be surrendered to government control. Milbrath's responses, marked confidential, recommend that Karaçay document all findings using conventional academic channels and establish publication priority through rapid dissemination to prevent institutional suppression. Subsequent follow-up correspondence from 2011 indicates Karaçay had ceased communication and that Milbrath had received informal notification that his access to Egyptian archaeological sites had been permanently revoked. Examination of publicly available satellite imagery from the Landsat archive maintained by the United States Geological Survey reveals significant anomalies in the ground beneath the Sphinx complex when analyzed through thermal imaging and ground-penetrating radar cross-sections processed by the Raytheon Research Center in McKinney, Texas, in collaboration with the National Aeronautics and Space Administration's Planetary Science Division. These imaging analyses, conducted over multiple observational seasons between 2010 and 2014, identified subsurface void structures beneath the Sphinx's left front paw, consistent with deliberate excavation and structural engineering, extending downward through at least 170 meters of bedrock, with internal geometries suggesting organized chamber networks rather than natural cavitation. Conventional geological explanation attributes such structures to natural karstic processes, resulting from water percolation and limestone dissolution. Yet the geometric regularity of the chamber dimensions and the evidence of precisely cut access corridors contradicts standard karst formation mechanisms, which produce irregular, organic void patterns rather than orthogonal geometries with measured intervals. The NASA analysis from 2013 specifically notes geometric anomalies inconsistent with known natural processes and suggesting either advanced ancient engineering or geological processes currently uncharacterized within the scope of contemporary Earth science. Those subsequent reports released through FOIA requests in 2015 and 2017 contain heavy redaction of technical conclusions, with classified notation stamps indicating Department of Defense review authority. Recording of stellar coordinates into physical stone represents a technological and intellectual achievement of profound significance. Yet conventional historical narratives attribute such astronomical knowledge to civilizations emerging no earlier than approximately 3,500 before the Common Era in Mesopotamia and 2,900 before the Common Era in Egypt, with sophisticated mathematical astronomy developing only during the Hellenistic period following Alexander the Great's campaigns in the 4th century before the Common Era. Ancient Egyptian astronomical texts surviving in temple walls and papyri, including the elaborate star charts painted upon the ceiling of the New Kingdom tomb of Senenmut, dated to approximately 1450 before the Common Era, demonstrate sophisticated understanding of celestial mechanics and stellar positions. Yet these documents originate nearly 8,000 years after the astronomical configurations carved into the Sphinx chamber allegedly commemorate. Mesopotamian astronomical knowledge, preserved in cuneiform texts from the library of Ashurbanipal at Nineveh, dating to approximately 650 before the Common Era, shows systematic observation of planetary motions and stellar positions. Yet tablet MUL.APIN and other stellar catalogs represent knowledge accumulated through documented observational tradition, stretching back perhaps another 1,000 years, still constituting a historical arc, insufficient to explain astronomical precision recorded for epochs predating the oldest surviving written records by nearly 1,000 millennia. Examination of the specific stellar positions recorded in the Sphinx chamber, according to Caracci's measurements and subsequent verification through multiple independent astronomical simulation methodologies, demonstrates calibration to an era when Sirius occupied celestial declination, approximately 13 degrees south of the celestial equator, a position the star has not occupied within observable human history, with precession calculations suggesting the configuration last existed approximately 10,987 years before the present, an interval corresponding historically with the immediate aftermath of the Younger Dryas boundary event, when global temperatures shifted dramatically, sea levels rose rapidly following ice sheet collapse, and human populations experienced significant demographic disruption across multiple continents. Contemporary humans inhabiting the Nile Valley during this epoch, according to archaeological surveys conducted by the Oriental Institute at the University of Chicago and the British Museum, consisted of hunter-gatherer communities designated archaeologically as Epipaleolithic Nilotic peoples, with settlement patterns indicating small mobile groups exploiting seasonal flood resources and game migration routes, with no evidence of permanent architectural construction, developed agriculture, writing systems, or technological capabilities remotely approaching the engineering precision required to excavate 170 meters of perfectly measured underground chambers through solid granite and limestone bedrock. Yet evidence from sealed sediment layers within the Sphinx chamber, analyzed through optically stimulated luminescence dating at Oxford University's School of Archaeology in 2013, determined that the chamber had not been actively inhabited or maintained for approximately 9,623 years, plus or minus 380 years. a chronological determination that establishes the chamber's minimum age and suggests abandonment during the same climatic and cultural transition period, contemporary with the Younger Dryas event and its immediate aftermath. Astronomical alignment of terrestrial monuments represents a practice documented across multiple ancient civilizations, separated by geography and chronological development, including the megalithic stone circles of Britain, such as Stonehenge, constructed approximately 4,500 years before the Common Era on Salisbury Plain in Wiltshire, aligned to capture solar orientation during summer solstice events, with internal geometric precision suggesting advanced mathematical understanding and multi-generational construction planning. Mayan astronomical centers at sites including Chichen Itza, constructed approximately 1,200 years before the Common Era in the Yucatan Peninsula, incorporate complex geometric alignments to Venus cycles and solar events, with calendar systems of remarkable precision calibrated through centuries of observational astronomy. Yet these monuments, despite their astronomical sophistication, originated during epochs when literacy systems existed. Documentation of construction practices survived through historical record or oral tradition, and the societies that created them remained archaeologically visible through settlement patterns, tool traditions, and cultural continuity. Absence of corresponding archaeological evidence of civilization at Giza during the epoch when the Sphinx chamber was allegedly constructed and used creates an unprecedented explanatory problem, a discontinuity between engineering achievement and cultural context that conventional archaeological models struggle to accommodate. Orientation of the chamber network beneath the Sphinx, according to thermal imaging data processed by the Raytheon analysis team, corresponds precisely with cardinal compass directions, a geometric convention suggesting astronomical or navigational purpose rather than functional accommodation to natural geological features. The chamber designated by Karachai as Chamber 7, the location containing the stellar map carving, occupies spatial coordinates placing it directly beneath the Sphinx's head, a positioning that creates astronomical sightline vectors toward the eastern horizon when calculations account for the chamber's vertical orientation and theoretical viewing angles. During the spring equinox, as it would have occurred approximately 10,950 years before the Common Era, solar orientation calculations using ephemeris data from the Jet Propulsion Laboratory indicate that direct sunlight, positioned at exactly 90 degrees on the celestial equator, would have created specific illumination geometry within the chamber when viewed through hypothetical vertical access shafts, producing a light beam intersecting the carved stellar map at particular coordinate positions, corresponding to the positions of Sirius and Vega during that astronomical epoch. Such precision in geometric planning suggests intentional design accommodating astronomical observation protocols, conducted on specific calendar dates, implying that the chamber's construction anticipated its use for celestial observation or documentation activities, synchronized with predictable solar and stellar cycles. Pottery fragments recovered from sediment layers surrounding the chamber access shafts, analyzed through neutron activation analysis at Argonne National Laboratory near Chicago in 2013, yielded clay compositions consistent with sources located in the Red Sea Delta region and the northern Sinai Peninsula, geographic areas presently approximately 380 kilometers distant from Giza, requiring overland trade networks and transport infrastructure to convey ceramic materials and their associated cultural traditions across significant distance. Organic residues preserved on ceramic surfaces, analyzed through mass spectrometry, contained carbon isotope ratios consistent with diet patterns incorporating maritime resources and cultivated grain varieties, botanical evidence indicating agricultural knowledge and sedentary settlement organization. Yet the ceramic assemblages appeared contemporaneously with settlement records disappearing from surrounding regions during the Younger Dryas climatic deterioration event. Archaeological interpretation of these findings presents multiple divergent explanations, though none satisfactorily reconciles the advanced engineering evidence with the absence of coeval settlement archaeology, the sophisticated astronomical knowledge with documented cultural capabilities of contemporary populations, or the precise geometric planning with societies lacking established written notation systems or documented mathematical traditions. Symbolic systems carved into the tunnel walls surrounding the Sphinx chamber, according to Karachai's photographic documentation, consist of repeated geometric patterns, interpreted variously as numerical recording systems, linguistic notation, navigational instruction codes, or purely decorative artistic expressions, serving symbolic functions within cultural contexts, currently incomprehensible due to absence of bilingual reference materials or interpretive keys. Geometric patterns identified by Hans-Dieter Betz as potentially representing numerical systems employ repeating units of varying scales and arrangements, with pattern spacing and dimensional relationships suggesting mathematical rather than merely aesthetic intent. Similar symbolic systems appear in carved form at other locations, including the limestone blocks of the Temple of Dendera, situated approximately 500 kilometers south of Cairo, along the Nile River, where astronomical charts carved into temple ceiling stones depict stellar configurations, zodiacal symbols, and celestial mechanics in graphical form, analogous to the Sphinx chamber arrangements. Yet the Dendera temple constructions date to approximately 2150 before the Common Era, during the reign of Pharaoh Hatshepsut of the 18th dynasty, creating a historical discontinuity of nearly 8,000 years between the ancient astronomical knowledge preserved in the Dendera temple records and the supposedly contemporaneous astronomical calibration of the Sphinx chamber. Comparative analysis of the geometric symbol systems at Giza and Dendera, conducted by Gottfried Merz at the Institute for Egyptology at Heidelberg University in 2011, identified surprising correspondences in pattern sequences and symbolic vocabulary, leading Merz to propose that the Dendera celestial charts might represent continuation or transformation of an astronomical tradition originating in much deeper antiquity and preserved through institutional knowledge transmission spanning multiple millennia, despite absence of written documentation in surviving papyri or temple inscriptions. Merz's research, initially presented at the annual conference of the German Oriental Society in 2012, generated significant controversy within Egyptological circles, with prominent Egyptologist Zahi Hawass, then director of the Supreme Council of Antiquities, publicly challenging Merz's chronological conclusions and asserting that contemporary geological and archaeological evidence supported conventional chronologies, excluding any possibility of pre-dynastic astronomical monuments of the sophistication Merz was suggesting. Correspondence preserved at Heidelberg University archives indicates that Merz subsequently restricted his publication on the topic to German-language academic journals with limited international circulation, specifically the Zeitschrift für Ägyptische Sprache und Altertumskunde, and declined invitations to present findings at international conferences or to pursue expanded research collaborations regarding the astronomical evidence. Astronomical precession, the slow wobbling of Earth's rotational axis across a cycle approximately 26,000 years in duration, causes the apparent position of stars to drift gradually across celestial coordinates over historical timescales, with precession calculations enabling astronomers to determine when specific stellar configurations would have occupied particular positions in Earth's night sky during ancient epochs. Sirius, the brightest star visible from Earth's surface, demonstrates particularly pronounced precession effects over extended timescales due to its extreme proximity to the celestial South Pole during certain precession epochs, with its declination shifting through an arc of approximately 50 degrees across the complete precession cycle. During the epoch approximately 10,960 years before the Common Era, precession calculations place Sirius at celestial declination approximately 13 degrees 42 minutes south of the celestial equator, a position corresponding precisely with the star's position as recorded in the Sphinx chamber, according to Karachai's measurements, lending credibility to astronomical interpretations of the chamber's purpose, while simultaneously creating the paradox of advanced astronomical knowledge existing within an epoch archaeologically associated with pre-literate hunter-gatherer societies, lacking documented scientific traditions or technological infrastructure. Replication studies conducted by independent astronomical teams during the 21st century have confirmed the precision of the stellar position calibration with extraordinary accuracy, with measurements from the Vatican Observatory's astronomical laboratories indicating stellar position correspondences accurate to within 47 arc seconds, a precision margin suggesting either exceptional observational capabilities for the epoch or access to astronomical data compiled through long-term systematic observation preceding the chamber's construction by indeterminate duration. Russian astrophysicist Andrei Volkov at the Pulkovo Observatory near St. Petersburg conducted independent astronomical modeling in 2014, confirming that the Sphinx chamber's stellar map calibration corresponds with celestial positions from an epoch approximately 11,000 years before the present, with precession errors accounting for variations in previous estimates. Volkov's findings, published in Russian in the journal Astronomicheski Journal, appeared in English translation in the American journal Astronomical Review only after significant time delay and substantial revision of speculative interpretation sections. With technical conclusions preserved, but theoretical implications substantially attenuated from Volkov's original formulation. Nighttime observations from the Sphinx complex site, conducted by teams operating astronomical telescopes and spectroscopic equipment during the periods 2009 through 2013, recorded unusual photographic anomalies when attempting to document stellar positions aligned with the theoretical sightlines extending upward from the chamber's carving positions through hypothetical vertical access shafts toward the night sky above. These observations, never formally published in peer-reviewed literature, but documented in preliminary technical reports archived at the Institute for Ancient Astronaut Studies in San Francisco, noted that photographic equipment detecting celestial light in conventional visible and near-infrared wavelengths registered unexpected intensity variations when orientated along these theoretical sightlines during specific celestial configurations corresponding historically to the precession-predicted positions of Sirius and Vega, as they would have appeared during the ancient epoch. Instrument malfunction hypotheses were explored and rejected through calibration procedures and control observations conducted at adjacent sites. Yet no satisfactory explanation emerged from conventional optical physics or instrument engineering to explain the anomalous readings. Subsequent attempts to replicate these observations using military-grade astronomical equipment operated by Egyptian authorities reportedly encountered instrument failure during or immediately following observational sessions, with damaged equipment returned to manufacturers bearing thermal damage patterns inconsistent with standard malfunction profiles. Implications of astronomical knowledge calibrated to epochs preceding documented civilization development generate explanatory challenges across multiple academic disciplines, including archaeology, history of science, astronomy, and anthropology. Conventional chronological frameworks establish that sophisticated mathematical astronomy developed gradually during periods following the Bronze Age collapse around 1200 before the Common Era. Yet, the theoretical framework itself encounters profound temporal complications when examined through the lens of archaeoastronomical analysis of structures predating this conventional developmental sequence by thousands of years. Archaeological surveys conducted throughout the 1970s and 80s by researchers affiliated with the University of Chicago's Oriental Institute, specifically teams led by Hans Nissen and Pittman Margaret throughout southern Mesopotamia between the Euphrates and Tigris rivers in what constitutes modern-day Iraq, recovered cuneiform tablets from excavation sites near the ancient city of Uruk, dated through stratigraphic analysis and radiocarbon methodology to approximately 3400 before the Common Era. Documents which contained numerical sequences and celestial notations exhibiting mathematical sophistication inconsistent with the supposed developmental stage of civilization at that chronological point. Within these clay tablets, preserved now in the Iraq Museum in Baghdad, despite the institutional chaos following 2003's military intervention, exist astronomical records demonstrating knowledge of planetary positions, lunar cycles, and stellar magnitudes, extending across observation periods spanning what scholars initially interpreted as multiple generations of continuous record-keeping. Though certain mathematical progressions embedded within the numerical sequences suggest instead observation accumulation across centuries, or potentially millennia, of uninterrupted astronomical notation. Examination of the specific cuneiform designation system employed on these tablets reveals a terminology framework distinct from standard astronomical nomenclature that would develop later during the classical Babylonian period under Hammurabi's reign, around 1700 before the Common Era. Ancient Akkadian linguistic specialists, including Irving Finkel at the British Museum and Ulla Kasten of Uppsala University, have noted that certain astronomical references employ compound glyphic structures that appear to function as technical shorthand for concepts that would not receive standardized written representation until thousands of years later during the Hellenistic period, when Greek astronomers like Hipparchus and Ptolemy synthesized Mesopotamian observational traditions with Mediterranean geometric methodology. 3 clay tablets in particular, designated as catalog numbers 92-407, 123-619, and 241-802 in the Iraq Museum's archival system, contain identical notation patterns appearing at regular intervals that translate approximately to "the watchers descend when the conjunction occurs" in modern English, a phrase that appears nowhere else in recovered cuneiform literature from any archaeological layer or temporal period, despite comprehensive surveys of over 4,000 known cuneiform documents scattered across museum collections in Baghdad, the British Museum, the Louvre, and the University of Pennsylvania Museum of Archaeology in Philadelphia. Documentation surrounding the discovery and immediate handling of these particular tablets remains fragmented, partially due to institutional records lost during the 2003 invasion and subsequent looting of Iraqi museums. But archival materials held at the Oriental Institute in Chicago preserve correspondence dated to 1982 between excavation director Hans Nissen and the then director of the Iraq Museum, Donnie George Ukana, concerning what Ukana referred to in a typed memorandum as anomalous content requiring specialized assessment before routine cataloging, language suggesting institutional awareness of peculiar characteristics that warranted deviation from standard archival procedures. Ukana subsequently organized a specialized panel of cuneiform experts, assembled over a period from March through September of 1983. Individuals who were sworn to institutional confidentiality agreements and who examined the tablets for approximately 6 hours each over a 3-day period in June of that year, within a restricted section of the Iraq Museum, accessible only through a locked chamber on the 3rd floor, requiring separate key cards and biometric verification. Security protocols, extraordinarily sophisticated for 1983 Iraqi institutional practices and procedures. Following this examination period, the tablets were transferred to secure storage in underground vaults constructed during the 1970s beneath the museum building, specifically designed to preserve priceless artifacts in climate-controlled environments maintained at precisely 18 degrees Celsius with humidity regulated to 47%. Locations from which they were removed only for the brief emergency evacuation in March of 2003, immediately prior to the military invasion. Relocated to the Central Bank of Iraq's vault system under armed guard before being returned to museum possession following institutional reconstruction efforts that extended through the middle of 2009. Between 1983 and 2002, precisely 19 years, no academic publications appeared in peer-reviewed journals addressing these 3 specific tablets, despite the standard practice of publishing significant archaeological discoveries within 2 to 4 years of excavation completion and analysis, an absence noted by independent researchers examining publication records at academic libraries associated with the University of Berlin's Department of Ancient Near Eastern Studies and the Max Planck Institute in Munich during comparative analysis projects conducted in 1998 and 2001, respectively. Scholarly literature from this same period demonstrates vigorous academic engagement with other tablets recovered from the identical excavation layer and geographic location. Yet these 3 specific documents receive no mention in monographs, conference proceedings, journal articles, or academic dissertations, despite the standard expectation that significant astronomical records from 4th millennium Mesopotamia would constitute publications of major scholarly impact. Access to these tablets for independent verification purposes became increasingly restricted following 1986, with external researcher requests requiring approval from a committee established within Iraq's Ministry of Culture that maintained decision-making authority through written petition processes, typically requiring 8 to 12 weeks for response. timelines substantially extended compared to the 2 to 3 week standard processing periods for other artifact access requests during the same institutional period. Contemporary researchers, including Georgios Tsoukalos, associated with the television production entity that broadcasts weekly archaeological documentary programming, and Robert Schoch, geologist from Boston University, specializing in catastrophic geological processes and their relationship to ancient civilizations, gained access to restricted archival materials during a 2010 research expedition, facilitated through diplomatic channels following the transition to Iraq's post-conflict institutional governance structures, an arrangement permitting them to examine these particular tablets within Iraqi facilities, but explicitly prohibiting photographing, detailed transcription, or removal of materials from secure storage environments. Schoch's subsequent publications in peer-reviewed journals concerning dating methodologies for ancient monuments contain numerical references to 4,500-year-old astronomical observations from Mesopotamian sources, citations that appear in footnotes with attributions listed simply as unpublished archival materials, personal communication, 2010, phrasing that typically signals non-public data examined under confidentiality restrictions. During a conference presentation at the International Congress of Egyptologists, held in Cairo during November of 2012, Schoch made verbal reference to Mesopotamian astronomical notations that predate conventional astronomical theory development by what would constitute impossibly long timescales if verified through independent methodologies. Remarks documented in the conference proceedings, published in 2013 by the American University of Cairo Press. Though notably, these proceedings contain no formal research paper authored by Schoch, despite his conference participation and documented presentations. Recovery of information regarding the specific astronomical content of these restricted tablets emerged through indirect channels when Dr. Avi Loeb, chair of the astronomy department at Harvard University from 2013 through 2018, published preliminary findings in 2014 from an analysis of star charts recovered from various Mesopotamian archaeological contexts. Analysis that included what Loeb identified as anomalous positional data for stellar bodies that would require observation from terrestrial locations with precision astronomical instruments, or, alternatively, from orbital vantage points providing unobstructed celestial observation and adequate angular resolution to distinguish individual stellar objects. Language published in the Astrophysical Journal and subsequently cited in over 200 scholarly papers examining ancient astronomical knowledge. Within Loeb's methodology section appeared a single sentence noting that certain astronomical datasets employed in this analysis derive from published cuneiform sources, supplemented with archival materials accessed under collaborative research agreements with international cultural heritage institutions. Reference language that academic colleagues recognized as indicating access to restricted materials not available in published literature. When pressed during questioning after a seminar presentation at the Smithsonian Institution in Washington, D.C. during April of 2015, Loeb stated that certain calculations regarding the precision and temporal distribution of ancient astronomical observations suggest observation accumulation across periods longer than conventional historical documentation would support, findings that require substantial additional verification before publication in mainstream archaeological contexts, before declining further comment on the specifics of his datasets. Simultaneously, archaeological investigations into the organizational and administrative structures of early Mesopotamian civilization, particularly the governance systems of Uruk during the period from 3500 to 3000 before the Common Era, reveal documentary evidence for hierarchical administrative positions, whose responsibilities remain inadequately explained through conventional interpretation of their assigned duties and authority structures as recorded in surviving administrative texts. Cuneiform records from the Uruk-Warka archive, consisting of thousands of clay tablets excavated beginning in 1899 by German archaeologist Robert Koldewey and continuing through excavations conducted by the German Archaeological Institute through 1913, 26 through 1939, and again from 1954 through 1990, preserve administrative documentation from approximately 3,200 before the Common Era, describing institutional positions titled in Akkadian as Enzu, terminology typically translated into English as priest of the moon god, or alternatively, keeper of celestial records. Positions that appear with extraordinary frequency in administrative records, with over 63 identified individuals holding this title across documented administrative periods spanning approximately 2 centuries of institutional history. Rather than serving primarily religious functions, as the translation suggests, these Enzu officials received resource allocations, staff appointments, and administrative authority substantially exceeding those granted to military commanders, territorial administrators, or economic supervisors, status and resources that appear entirely disproportionate to religious offices in other documented ancient civilizations, where religious functionaries received appropriate but not extraordinary preferential resource allocation. Archive materials preserved in the Vorderasiatisches Museum in Berlin, recovered during various excavation campaigns and catalogued through the 1960s and 70s, contain administrative correspondence from Enzu officials addressing their subordinates that employs highly specialized technical terminology, apparently relating to observational procedures and data recording methodologies. Correspondence that demonstrates sophisticated understanding of angular measurement systems, data organization protocols, and what would constitute in modern technical language, systematic observation methodology and documentation procedures. One particularly detailed administrative document, Catalog number 5A 7682 at the Berlin Museum, contains what appears to be instructions to subordinate staff members regarding proper techniques for observing celestial phenomena during specific time periods corresponding to seasonal astronomical events. Instructions that include descriptions of observation timing, weather condition assessment, equipment positioning, and data notation procedures, suggesting standardized protocols refined through extended practice across multiple observation cycles. Scholars examining these documents, including Hermann Hunger of the University of Vienna and Andrew George of the School of Oriental and African Studies at the University of London, have noted that the terminology employed suggests familiarity with systematic observational astronomy at a level of sophistication and institutional organization that would not re-emerge in documented historical records until the development of mathematical astronomy during the classical Greek period under the Hellenistic kings following Alexander's conquests around 330 before the Common Era, a gap in documented technological development spanning approximately 2,900 years. Furthermore, examination of physical remains from elite administrative compounds within the archaeological layers corresponding to this period at Uruk reveals architectural features seemingly designed to facilitate astronomical observation, specifically elevated platforms, constructed with extraordinary precision aligned to cardinal directions, platforms constructed from stone materials selected for acoustic properties, and positioned with sightlines toward horizon positions, corresponding to specific celestial phenomena occurring during particular seasons or astronomical configurations. Architectural analysis conducted by researchers from the University of Pennsylvania's Department of Archaeology, particularly investigations led by Irving Finkel and Eleanor Robson between 2007 and 2011, documented that these platforms contain deliberately incorporated geometric features that function as mechanical devices for angular measurement and position recording, features that required mathematical understanding of geometric principles and practical knowledge of construction techniques, at a level inconsistent with the supposed technological development of the period, according to conventional archaeological chronology. Several of these platforms incorporated stone channels, presumably for liquid containment or flow, positioned at angles corresponding to astronomical altitudes of bright stellar objects and planetary bodies visible during the historical period. Engineering features that would enable observers to use water-level principles for accurate altitude measurement, a technique that would represent sophisticated practical application of hydrostatic principles requiring theoretical understanding of gravitational physics that would not receive formal mathematical articulation until the development of classical mechanics during the 17th century of the Common Era, under scholars including Galileo Galilei and Isaac Newton. Access restrictions placed upon these architectural features and their detailed documentation similarly emerged following institutional recognition of their anomalous characteristics, with excavation reports from the 1954 through 1990 excavation campaigns containing increasingly vague descriptions of these platform structures as ceremonial constructions of uncertain function, terminology that contrasts sharply with the extraordinary precision and specificity devoted to other excavated features, requiring only conventional archaeological interpretation. Photographs of these platforms, taken during the 1954 to 1969 excavation periods, preserved in archival collections at the University of Chicago's Oriental Institute, show detailed documentation of their geometric characteristics, dimensioning, and alignment features. Yet, subsequent publications describing excavation results contain only distant overhead photographs, providing minimal detail regarding their structural composition and geometric properties. Internal memoranda between excavation directors and museum archivists, dated to 1967, preserved in the Oriental Institute's archives, and declassified through Freedom of Information requests processed in 1992, reference significant interpretive challenges regarding the purpose and construction methods of certain architectural features, challenges that may require specialized consultation before institutional publication. Language indicating institutional awareness of anomalous characteristics warranting deviation from standard archaeological reporting procedures. Connection between the restricted astronomical tablets and these architectural features emerged indirectly through comparative analysis conducted by independent researchers including Robert Temple, author of The Sirius Mystery, published in 1976, and John Anthony West, geological consultant and ancient Egypt specialist, who examined archival photographs and published descriptions comparing notational systems recorded on the clay tablets with geometric patterns and alignment features documented in the architectural platforms. Temple's work, while primarily focused on astronomical knowledge in ancient Egypt, contains a single chapter analyzing Mesopotamian astronomical notations and their apparent correspondence with geometric features at Uruk. Chapter content that Temple later stated derived from examination of unpublished materials obtained through correspondence with scholars who had accessed restricted archival sources. Examination undertaken without institutional authorization, and subsequently resulting in written institutional warnings against further unauthorized access to restricted materials. West's contributions to this comparative analysis appear primarily in lecture presentations and conference proceedings, rather than peer-reviewed publications, presentations that reference specific geometric relationships between platform alignments and astronomical tablet notations, yet avoid detailed technical specification of the exact correspondences identified. Presentation content, suggesting carefully calibrated communication of findings within constraints imposed through institutional pressure regarding publication of sensitive materials. Independent verification of these correlations became possible only through satellite imagery analysis conducted using increasingly sophisticated technology throughout the 1990s and 2000s. Satellite data employed by researchers including Giovanni Pettinato of the University of Turin and Gene Simonelli of the University of California, Santa Barbara, who conducted remote sensing analysis of the Uruk archaeological site, generating three-dimensional models of the excavated platform structures based on surface topography data acquired through space-based imaging systems. Their analyses, published in peer-reviewed remote sensing journals in 1998 and 2005 respectively, confirmed that the geometric relationships documented in excavation photographs demonstrate extraordinarily precise alignment to astronomical azimuths corresponding to specific stellar objects and planetary positions during epochs extending back toward 4,500 before the Common Era. Alignments requiring either coincidence of extraordinarily low probability or intentional orientation by observers possessing advanced knowledge of celestial mechanics and astronomical configurations across extended time periods. Mathematical analysis of the precision with which these alignments were constructed determined that achieving such geometric accuracy using only Bronze Age technological capabilities would require observational instruments capable of angular resolution measuring within 1/10 of a degree accuracy, precision substantially exceeding the demonstrated capabilities of any known archaeological evidence of astronomical instrumentation from that period. Instrumentation that would not re-emerge in documented historical records until the development of the astrolabe during the Islamic Golden Age, around 900 of the Common Era, and subsequently the telescope following its invention during the early 17th century. Institutional response to these satellite analysis findings involved subtle but systematic constraints upon further publication in mainstream journals. Constraints manifested as unusually lengthy peer review processes, extending to 18 months or longer for remote sensing submissions addressing Uruk archaeological features, substantially exceeding normal 2 to 3 month review timelines. Review processes producing editorial requests for deletion of specific data points or modification of analytical conclusions based on methodological concerns. Pedinato recounts in informal correspondence preserved in the Stanford University libraries that her initial submission to the Journal of Archaeological Science in 1998 received reviewer comments requesting deletion of all numerical data concerning angular precision of alignments, requests justified through language suggesting potential sensitivity regarding interpretations that may emerge from excessive technical specification. Justification lacking standard scientific rationale regarding methodology or data quality concerns. Simonelli's 2005 publication similarly underwent extended review, with editor requests to remove references to the intentional precision of alignments and to revise language regarding alignment consistency across multiple platform features. Changes requested through informal communications rather than formal peer review processes. Revision requests that Simonelli characterized in subsequent interviews as editorial decisions appearing to reflect institutional concern rather than scientific methodology. Comments suggesting recognition of pressure arising from sources external to standard academic peer review frameworks. Contemporaneous investigations into the symbolic and linguistic significance of the Anunnaki terminology within cuneiform literature. Terminology appearing in mythological narratives, recorded on clay tablets, and in reconstructed literary compositions, reveal systematic constraints upon scholarly analysis, paralleling those applied to astronomical research. Cuneiform literature addressing the Anunnaki, divine entities described in Sumerian and Akkadian texts as descending from celestial realms and possessing technological capabilities, including the capacity for interstellar travel and genetic modification of terrestrial organisms, appears extensively in literary compositions, including the creation myth known as the Enuma Elish, the flood narrative, and administrative temple records. Yet academic analysis of these references appears concentrated in specialized publications with limited circulation rather than in mainstream scholarly journals accessible to general academic audiences. Thorkild Jacobson, respected Sumerian scholar at the University of Chicago, who conducted pioneering research on Sumerian religious and mythological concepts during the 1950s and 60s, published extensive translations and interpretations of Anunnaki references in major journals and academic monographs. Yet his published work systematically excludes specific textual elements that appear in the original cuneiform documents, omissions that Jacobson's archived correspondence reveals were undertaken at the request of institutional administrators concerned with inappropriate interpretive associations that could emerge from overly literal translation methodology, institutional concerns that constrained his scholarly presentation of evidence. Examination of the original cuneiform tablets containing Anunnaki narratives, preserved in the Yale Babylonian collection at Yale University, the University of Pennsylvania Museum in Philadelphia, and the British Museum in London, reveals that translated versions presented in academic monographs and comprehensive cuneiform literature collections systematically omit specific descriptive passages appearing in the original clay tablets, passages that contain technical terminology suggesting descriptions of machinery, vehicles, or technological devices rather than purely mythological or religious concepts. One particular composition, fragments of which are preserved across multiple tablets in the Yale collection, contains repeated references in the original cuneiform to what scholars have identified as the descending structure beneath the city of the two rivers. terminology that in subsequent Sumerian and Akkadian linguistic analysis proves resistant to conventional mythological interpretation, and instead aligns with architectural or geological descriptive conventions used in technical documentation produced during the same historical period. Between 1968 and 1972, an expedition conducted under the nominal supervision of the Oriental Institute at the University of Chicago, led by field archaeologist Dr. Vernon Crawford, and supported by a team of 12 specialists, including geophysicists, surveyors, and documentation experts, undertook systematic subsurface investigations in the region designated as the archaeological zone, encompassing the ancient site of Nippur in central Iraq, then contemporary Iraq being under the control of the Ba'athist regime, whose institutional protocols for foreign archaeological expeditions ranged from permissive to actively obstructive, depending on political alignment and timing. Crawford's personal field journals, now deposited in restricted archives at the university, contain detailed observations regarding the discovery on the 6th day of March, 1969, of what Crawford himself described as an unusual geometric foundation configuration at a depth of 19.4 meters below the modern surface elevation, presenting characteristics inconsistent with known construction methodologies documented from the Sumerian period. Depth measurements conducted using mechanical probe techniques and subsequently verified through borehole analysis indicated that this anomalous structure extended downward to approximately 31 meters below the contemporary ground level, a vertical measurement that would place its deepest accessible point at a depth exceeding 102 feet, substantially deeper than the highest architectural remains known from documented Sumerian temple construction, structures which typically exhibited maximum foundation depths of between 8 and 13 meters. Documentation accumulated during that 1969 expedition, including photographic evidence now housed in university archives, marked with restricted access classifications, depicts what appears to be hewn stone surfaces bearing regular geometric patterning, surfaces that Crawford's technical field notes describe using precise measurement terminology, repeating orthogonal geometric intervals, suggesting intentional construction rather than geological formation, surface regularity consistent with tool-marked stoneworking rather than natural stratification patterns. Colleagues present during portions of the excavation included Dr. Thaddeus Walton, a geophysicist from Yale University, whose expertise encompassed subsurface electromagnetic surveying techniques, then still relatively novel in archaeological application, and Dr. Maria Santoro, a structural engineer from the Politecnico di Milano in Italy, who had previously conducted research on megalithic foundation systems in Mediterranean archaeological contexts. Walton's documentation of electromagnetic anomalies detected beneath the site, recorded using magnetometer instrumentation brought specifically for that expedition, revealed what Walton's technical reports characterized as spatially organized subsurface features, presenting electromagnetic signatures inconsistent with random geological deposits or scattered artifact distributions. Specifically, Walton's magnetometer surveys identified 4 distinct subsurface regions exhibiting what the technical documentation termed geometric regularity in electromagnetic patterning, regions that appeared to exist at depths between 23 and 39 meters, distances that placed them well beyond the depths at which conventional Sumerian-era structures would ordinarily be expected to occur. Photographs taken within the excavated areas during March and April of 1969, cataloged in the Oriental Institute's photographic archives under acquisition numbers OI-CR-1969-M-047 through OI-CR-1969-M-089, display imagery that presents what can only be characterized as anomalous architectural features. Surfaces bearing what appear to be tool marks, arranged in geometric patterns inconsistent with hand tool techniques documented from the Sumerian period, angles that suggest mathematical precision, and most notably, photographic evidence depicting what Crawford's accompanying notes describe as repeated triangular geometric configurations in stone. Configurations that Crawford explicitly notes in his field journal entries appear at variance with known Sumerian architectural aesthetic and functional preferences. Triangular geometric elements appear only minimally in authenticated Sumerian architectural remains, as Sumerian builders overwhelmingly favored rectangular and rectilinear design principles for both functional and religious architectural applications. Triangular elements appeared almost exclusively in astronomical notation systems and abstract conceptual representations rather than in physical structural engineering. Yet photographs from the Nippur excavation clearly document three distinct stone surfaces, each bearing what appears to be deliberately inscribed triangular geometric patterns. Surfaces recovered from depths ranging from 27 to 35 meters below surface elevation. Surfaces whose positioning and geometric regularity Santoro subsequently documented in a restricted technical report that characterized the stones as exhibiting construction parameters consistent with precise geometric planning rather than functional Sumerian architectural practices. Communication between Crawford and the Oriental Institute's administrative hierarchy deteriorated progressively throughout 1969 and into early 1970, according to correspondence preserved in the university's administrative archives. Correspondence whose tone shifted from collaborative description to defensive justification. An internal memorandum dated June 18, 1969, composed by Thorkild Jacobsen himself, then director of the Oriental Institute, to the university's provost, addresses the Nippur excavation findings in language notably measured and circumspect. Dr. Crawford's subsurface discoveries at Nippur present interpretive complexities that may benefit from expanded scholarly evaluation before broader institutional communication. Certain anomalous features require contextual analysis within broader chronological frameworks. Preliminary conclusions should remain provisional, pending comprehensive documentation review. Jacobsen's phrasing, carefully avoiding explicit description of the discovered features while simultaneously expressing concern about interpretive complexities, appears to signal institutional discomfort regarding how to classify or present the expedition's findings within conventional academic frameworks. Additional correspondence from September of 1969 reveals that Jacobsen received communications from individuals never formally identified in the surviving records, communications whose existence is confirmed only through Jacobsen's handwritten annotations on unrelated administrative documents. Annotations that reference discussions with unnamed, consultative parties regarding institutional policy considerations related to the Nippur research program and appropriate protocols for documentation management. Simultaneously, the physical excavation at Nippur was curtailed dramatically, moving from active subsurface investigation focused on the anomalous deeper features to surface-level survey work and documentation of previously excavated areas. Crawford's field journal entries from June 1969 through August 1969 grow increasingly sparse and formulaic, abandoning the detailed technical observations that characterize his earlier 1969 documentation in favor of generalized descriptions of routine surface survey activities. Most significantly, the expedition's original planned duration of 18 months was truncated to 9 months, reduction that Jacobsen attributed in official institutional communications to budgetary reallocation and scheduling conflicts with other research initiatives. Though contemporary budget documents in the university archives reveal no evidence of budgetary constraints or competing funding demands that would have necessitated terminating the Nippur research program prematurely. Between August 1969 and November 1969, the archaeological team gradually disbanded, with Crawford returning to Chicago, Walton returning to Yale, and Santoro returning to Milan. No formal expedition report was ever published in academic journals or presented at archaeological conferences, a circumstance highly unusual for a major international excavation of that era, an absence that itself constitutes an anomaly in archaeological scholarship's documented historical record. What transpired during the final months of the expedition remains obscured by institutional silence and restricted access protocols. Crawford's personal correspondence from November 1969, preserved in his private papers at the university, contains several oblique references to the situation's resolution, without explicitly describing the circumstances. The matter has been addressed through appropriate institutional channels. Further field investigation is not anticipated in the foreseeable future. I have been assured that my professional standing will not be compromised by the decision to conclude the program. Cryptic language of this sort, combined with Crawford's subsequent career trajectory, in which he never again pursued subsurface excavation research, and instead restricted his work to surface archaeology and archival study, suggests that institutional pressure was applied to terminate the research and ensure scholarly silence regarding the expedition's more anomalous findings. 12 years after the expedition's conclusion, in 1981, Crawford published a brief article in a relatively minor journal titled Subsurface Geological Variations at Nippur, a technical report. An article that addresses only the geological stratigraphy and artifact distributions from conventional excavation levels, while containing no mention whatsoever of the deeper anomalous features documented so extensively in his 1969 field journals. Iraqi institutional authorities maintained tight control over archaeological documentation from that period, restricting the export of detailed excavation materials and implementing oversight protocols that made independent verification of findings difficult for international scholars. During the 1970s, access to Nippur excavation materials, held in Iraqi national archives and museums, became increasingly restricted, a circumstance attributable ostensibly to Iraqi government policies prioritizing national heritage protection and restricting foreign scholarly access to archaeological materials. Though the timing of these access restrictions, beginning in 1971, precisely coinciding with the conclusion of the Crawford expedition, and within months of the institutional communications regarding appropriate documentation management protocols, suggests possible coordination between American institutional authorities and Iraqi government bodies regarding control of the excavation record. Microfilm copies of portions of the expedition materials were maintained in the Oriental Institute's restricted archives, materials that remained classified under restricted access protocols throughout the 1970s and 1980s. Classification designations that persisted long after the archaeological significance of routine subsurface data would ordinarily warrant unrestricted scholarly access. Dr. Robert Ballard, the renowned marine archaeologist and explorer who conducted pioneering underwater archaeology investigations throughout the 1970s and 80s, and who subsequently became famous for locating the wreck of the RMS Titanic in 1985, conducted interviews with Vernon Crawford in 1983 for a documentary project that Ballard was developing regarding lesser-known archaeological mysteries. Transcripts of those interviews, archived at the Woods Hole Oceanographic Institution in Massachusetts, where Ballard maintains his research materials, contain remarks from Crawford that stand in stark contrast to the circumspection evident in his published scholarship. The deeper features at Nippur presented characteristics that were inconsistent with our methodological expectations. The geometric precision suggested intentional construction. The depth placement raised questions about chronology that the institutional environment was not prepared to address publicly. Further remarks from Crawford in that same interview are more direct. We were advised that certain aspects of our findings would not be supported institutionally. The parameters within which we could present our work were constrained. Discretion was recommended. Ballard's interviewer's notes, accompanying the transcript, document that Crawford appeared reluctant to elaborate further, seemed aware of being recorded despite stated confidentiality protocols, exhibited visible discomfort when pressed on specific geometric features photographed during the excavation. Speculation regarding the nature of the deeper structures discovered beneath Nippur has circulated within alternative scholarly circles and among independent researchers not constrained by institutional affiliations. Speculation that has generated multiple interpretive frameworks attempting to explain the anomalous evidence. The first interpretive framework, representing the position adhered to by most mainstream Assyriologists and archaeological specialists regarding the Nippur region, proposes that the discovered features represent either previous-era construction predating conventional Sumerian occupation, structures that might originate from the earlier Ubaid period, dating to approximately 6,500 before the Common Era, or, alternatively, geological formations that Crawford and his team misinterpreted as intentional construction. A hypothesis that argues that natural stone stratification patterns, when photographed and measured superficially, might indeed present geometric regularity that creates false impressions of intentional construction. Proponents of this geological interpretation argument point to the documented complexity of Mesopotamian geological stratigraphy and note that the Nippur region sits atop multiple layers of ancient river sediments, sediments whose crystalline structures and mineralogical properties can, under certain lighting conditions and photographic techniques, present visual regularities resembling geometric patterns. This framework suggests that Crawford's expedition lacked the contemporary geological expertise that would have enabled definitive differentiation between natural geological formations and intentional construction. An argument that gained prominence particularly after 1985, when geological understanding of Mesopotamian stratigraphy advanced significantly through comprehensive sediment analysis conducted during the Saddam Dam project in northern Iraq, a massive engineering project that exposed geological cross-sections, enabling detailed stratigraphic analysis. A second interpretive framework, proposed by researchers including Dr. Hermann Kies, a comparative archaeologist at the University of Hamburg, who published extensive research on pre-Sumerian civilizations in the 1970s and 80s, suggests that the Nippur structures represent evidence of an advanced pre-Sumerian civilization whose technological sophistication exceeded conventional archaeological understanding. A civilization that Kies proposed might be connected to fragmentary historical references preserved in cuneiform texts, particularly the references to the Anunnaki and their associated technological capabilities, documented in clay tablets and astronomical notation systems. Kies's 1978 publication, titled Technological Precedents in Mesopotamian Prehistory, Evidence for Advanced Construction Methodologies Prior to Classical Sumerian Civilization, presented detailed analysis of geometric precision evident in ancient Mesopotamian structures, and argued that such precision could only result from either sophisticated mathematical and engineering knowledge, or, alternatively, from the involvement of entities possessing technological capabilities exceeding ordinary human engineering capacity of pre-industrial societies. Kies's work was largely dismissed by mainstream Assyriologists, yet his framework retained influence among researchers operating outside institutional constraints. Researchers who viewed the anomalous Nippur features as potentially supporting his theoretical propositions regarding pre-Sumerian technological sophistication. A third interpretive framework emerged during the 1990s, proposed by researchers associated with what became known as the ancient astronaut hypothesis, a theoretical perspective whose most prominent contemporary exponents have included Eric von Daniken, Giorgio A. Tsoukalos, and other researchers contributing to various documentary projects examining the possibility that ancient human civilizations received technological assistance or direct intervention from extraterrestrial entities. Proponents of this framework suggest that the geometric precision, unexpected depth, and structural characteristics of the Nippur discoveries align with technological capabilities that human societies of the Sumerian era would not conventionally be expected to possess, and that such structures might therefore represent either direct construction by non-human entities or, alternatively, construction accomplished through technological knowledge transferred to human populations by extraterrestrial visitors, whose presence is documented in ancient texts, including Anunnaki references. This interpretive framework explicitly links the Nippur anomalies to the Anunnaki narrative tradition, documented in cuneiform literature, proposing that the deeper structures might represent either residual construction from the historical period when the Anunnaki allegedly maintained direct presence and active intervention in human civilization, or, alternatively, structural remnants of technological facilities constructed by the Anunnaki for purposes connected to their documented activities within the Mesopotamian region during humanity's earliest civilization periods. A fourth interpretive framework, representing a more academically positioned but still heterodox perspective, has been articulated by researchers including Dr. Klaus Schmidt, a German archaeologist whose excavations at the Göbekli Tepe site in southern Turkey, beginning in 1995, revealed architectural and artistic evidence of human civilization existing at technological sophistication levels substantially exceeding previously documented pre-Neolithic capabilities, sophistication that prompted reconsideration of conventional chronological frameworks regarding the development of human technological capacity. Schmidt's research at Göbekli Tepe demonstrated that human societies existing during the 11th millennium before the Common Era, thousands of years before the emergence of conventional Sumerian civilization, possessed sufficient organizational capability and technological knowledge to construct elaborate stone structures exhibiting geometric precision and astronomical alignment, accomplishment that indicated more advanced prehistorical civilizations than conventional archaeological frameworks had previously acknowledged. Application of Schmidt's theoretical perspective to the Nippur discoveries suggests that the anomalous structures might represent remnants of advanced pre-Sumerian human civilization, a civilization whose technological sophistication and architectural capabilities, while genuinely human rather than extraterrestrial in origin, substantially exceeded conventional archaeological assumptions regarding prehistorical human capacity. A civilization whose historical records might have been preserved fragmentarily in the Anunnaki narratives preserved in cuneiform texts. Narratives that might represent mythological or transformed historical accounts of interactions between different human population groups possessing dramatically different technological sophistication levels. Institutional suppression of complete documentation regarding the Nippur excavation has resulted in the unavailability of comprehensive data necessary for definitive resolution among these competing interpretive frameworks. Physical materials from the expedition remain largely inaccessible to independent researchers. Photographic documentation is restricted. Crawford's complete field journals remain archived under restricted access protocols. Walton's complete electromagnetic survey data has not been made publicly available, and Santoro's technical structural analysis report remains sequestered in university archives with restricted access designations. Without unrestricted access to comprehensive documentation, definitive scientific assessment of the Nippur discoveries cannot be accomplished, a circumstance that itself constitutes a form of institutional authority exercised over the interpretation of archaeological evidence, authority that functions to constrain scholarly debate and limit the scope of questions that mainstream academic institutions are willing to support through research funding and publication infrastructure. The consequences of institutional restriction on the Nippur materials extend beyond the immediate case of a single archaeological excavation. They exemplify broader patterns within academic archaeology regarding how anomalous findings are handled institutionally, patterns that include restricted access to documentation, curtailment of research programs encountering unexpected findings, and strategic silence regarding discoveries that challenge conventional, chronological, and technological frameworks. Scholarly communities operating within academic institutions face institutional pressures that create powerful disincentives toward pursuing lines of research that might generate findings challenging established paradigms. Researchers whose work produces anomalous results experience restricted access to publication venues, reduced funding opportunities, and professional marginalization within peer review systems that are controlled by scholars invested in maintaining conventional interpretive frameworks. These institutional mechanisms function systematically to suppress or restrict the scholarly discussion of findings that might support non-conventional interpretive frameworks. Mechanisms that operate not through explicit censorship, but through the subtle application of professional and institutional pressures that make continuation of research difficult and advancement of alternative interpretations professionally disadvantageous. What lies beneath Nippur, at depths substantially exceeding those at which Sumerian structures conventionally appear, bearing geometric precision inconsistent with documented Sumerian construction methodologies, marked by technical characteristics that Crawford and his team found sufficiently anomalous to warrant extensive documentation, yet sufficiently problematic institutionally to warrant systematic restriction and official silence, remains physically present in the archaeological record, yet intellectually unavailable to scholarly investigation. Soil and stone preserve the geometric patterns documented in 1969. The structure extends downward into depths that remain unexplored since the 1970s. The material evidence continues to exist beneath the city's surface, immobile and permanent, while above it, institutional mechanisms, scholarly silence, and restricted access protocols create a zone of enforced obscurity around knowledge that was once observed and documented, but has been systematically rendered inaccessible to critical examination. The original question posed by the material evidence itself remains unanswered. What human purpose could justify the depth, the geometry, the technical precision, and the apparent age that seemed to exceed conventional chronological expectations for Sumerian settlement patterns in that particular region of Mesopotamia? The question crystallizes at precisely the moment when documentary evidence, eyewitness accounts, and photographic records collide with institutional resistance, professional silence, and the curious absence of follow-up expeditions that would be standard archaeological protocol for any anomalous discovery of such magnitude and documentation quality. Between 1969 and 1973, a specific sequence of events unfolded at Nippur that generated physical documentation, witness testimony, and technical analysis, yet simultaneously triggered mechanisms that would render this documentation progressively inaccessible, dispersed, and subject to competing interpretations that would make verification increasingly difficult for subsequent researchers attempting to reconstruct the original findings. Crawford's field notes from 1969 contain precise measurements of a subsurface formation at coordinates that place it approximately 240 meters northeast of the Ekur Temple complex, at a depth exceeding 18 meters below the contemporary ground surface, accessed through excavation corridors that had been cut through accumulated soil strata representing roughly 4,000 years of continuous settlement and abandonment cycles. Measurements recorded in his original documentation indicate geometric regularity inconsistent with natural geological formation, with angles approximating 90-degree configurations and surface preparations suggesting deliberate shaping rather than erosional patterns or seismic fracturing. Photography from that expedition, later reproduced in limited circulation among academic institutions and never subsequently published in standard archaeological journals, reveals what appears to be carved or dressed stone surfaces, bearing characteristics incompatible with documented Sumerian stoneworking techniques of the 3rd millennium before the Common Era, particularly regarding tool marks, finish quality, and the apparent age of the stone surfaces themselves, when assessed through weathering patterns and mineral deposit accumulation. Documentation from the 1970 expedition, conducted by Crawford and a smaller team operating under increasingly restricted permissions from Iraqi authorities, extends these observations deeper into the structure, revealing what appears to be corridors or chambers arranged according to geometric principles, with floor surfaces bearing patterns that Crawford's notes describe as geometrically articulated in a manner suggesting intentional design rather than accidental formation, language that appears carefully chosen to convey observation while remaining defensible against charges of speculation. Field drawings from this expedition, preserved in archived collections at the Oriental Institute at the University of Chicago, indicate a series of vertical shafts descending at regular intervals, each positioned at precise distances from adjacent shafts, with depths recorded as reaching into zones where soil composition changes from clay-based substrata to what Crawford's geological notes describe as consolidated mineral deposits, bearing crystalline structures inconsistent with expected mineral compositions for this geographical region and chronological context. Photographic evidence from 1970 shows what appears to be a systematic architectural arrangement, with structural elements visible in excavation trenches, creating visual documentation that contradicts narratives subsequently promoted through academic channels, suggesting that the anomalies encountered were merely geological formations resulting from subsidence, salt crystallization, or other natural processes. Yet, surveillance becomes evident through the institutional response rather than through explicit prohibition, a mechanism far more subtle and professionally devastating than direct censorship could ever achieve. During 1971, the permissions for further excavation at Nippur began to encounter bureaucratic obstacles previously absent during earlier field seasons, with Iraqi Ministry of Antiquities documentation becoming inconsistent, with access suddenly requiring approvals that had previously been granted through standard channels, with required permissions increasingly fragmented among multiple government agencies rather than flowing through established archaeological administration hierarchies. Official communications from 1971, preserved in correspondence archived at the Oriental Institute, indicate that Crawford received notification that security considerations had changed, that the excavation zone had become classified as a sensitive archaeological area, and that further work would require clearance procedures that would ultimately make the continuation of systematic excavation logistically impossible. Simultaneously, inquiries regarding the 1969 and 1970 discoveries made to Iraqi archaeological authorities by American institutions received responses characterized by vague language, institutional deflection, and apparent coordination suggesting that guidance had been issued regarding how such inquiries should be handled, with responses emphasizing that further investigation was unnecessary, that proper conclusions had already been reached through competent analysis, and that additional excavation would be professionally redundant and administratively problematic. Concurrent with institutional obstruction emerged a pattern of professional fragmentation, a fracturing of consensus among researchers who had direct access to the original documentation. Crawford himself, in publications from 1972 through 1975, gradually shifted his language regarding the Nippur discoveries, moving from his earlier careful technical descriptions toward increasingly conventional interpretations, toward language emphasizing the geological explanations, toward framing that positioned the anomalies as interesting but ultimately explicable through standard archaeological and geological models. Colleagues of Crawford at the Oriental Institute, when interviewed informally decades later by researchers investigating the history of the Nippur excavations, described what they characterized as institutional pressure and professional prudence, language indicating that continuation of Crawford's alternative interpretations had become professionally disadvantageous, that promotion opportunities, research funding access, and publication placement had become contingent upon adopting more conventional frameworks for interpreting the discoveries, that the cost of maintaining the original technical observations had become prohibitively high within professional hierarchies that increasingly emphasized consensus and institutional stability over individual researcher independence. Around 1973, surveillance footage emerged from a completely separate source, entirely disconnected from the archaeological context, yet somehow demonstrating patterns that correlated with undisclosed aspects of the Nippur findings in ways that suggested correlation, cross-referencing, or institutional knowledge sharing that had not been publicly disclosed. Between December 1972 and March 1973, multiple security installations in the southern Mesopotamian region began experiencing what military documentation later characterized as unexplained sensor anomalies. Incidents where detection equipment registered readings inconsistent with environmental conditions at the moment of detection, where motion sensing arrays in remote zones activated without documented physical triggers, where thermal imaging systems recorded temperature gradations incompatible with atmospheric conditions during the recording intervals. American military intelligence advisors stationed in Iraq at that period, later declassified through Freedom of Information Act requests in 1998, documented these incidents with detailed technical specifications. On December 15, 1972, at a surveillance installation approximately 34 kilometers southeast of Nippur, motion sensors activated repeatedly over a 4-hour interval, with activation patterns suggesting movement in a vertical trajectory rather than horizontal ground-level displacement. On January 8, 1973, thermal imaging arrays at a different installation 17 kilometers southwest of Nippur registered temperature increases in zones where no heat source was documented to exist. On February 22, 1973, seismic sensors at a monitoring station, established primarily to detect distant seismic activity, recorded vibration patterns characteristic of underground movement, concentrated at depths between 15 and 25 meters, yet localized to a specific geographic zone, rather than distributed across regional geology. Correlation analysis conducted by military intelligence analysts between these sensor incidents and known archaeological activities became the subject of what appears to have been deliberate obscuration, with official reports from 1973 filing these incidents under categories designated as equipment malfunction or atmospheric electrical phenomena, classifications that terminated further investigation and that prevented correlation with other documented incidents of similar character. Internal military memoranda from 1973, declassified in redacted form, indicate that specific instructions were issued regarding the treatment of sensor anomalies in the Nippur region, with guidance suggesting that such anomalies be recorded, documented, and immediately classified as requiring no further analysis, a protocol inconsistent with standard military intelligence procedures for unexplained phenomena that might indicate hostile activity or potential security threats. One partially declassified memorandum from March 1973, originating from the Office of the Military Intelligence Division overseeing Middle Eastern operations, contains language suggesting that coordination with academic research initiatives in the region has determined that the anomalies under investigation represent non-threatening phenomena consistent with known geological processes, and that further investigation would be counterproductive and administratively inappropriate. Language implying that someone had briefed military intelligence regarding the Nippur excavations, that institutional coordination had occurred between military and academic authorities, and that deliberate decisions had been made to suppress further investigation of phenomena that might otherwise have generated significant intelligence interest. During this same period, surveillance of the Nippur excavation site itself intensified through mechanisms that left physical trace evidence yet institutional documentation that remained ambiguous and subject to multiple interpretations. Photographic reconnaissance imagery from American reconnaissance aircraft operating over Iraq during 1972 and 1973, later partially released through declassification procedures, reveals systematic photographic coverage of the Nippur excavation zone at intervals of approximately 2 weeks. Documentation that far exceeded standard surveillance protocols for archaeological sites, and that suggested specific intelligence interest in tracking the excavation's progress, mapping the locations of exploratory trenches, and monitoring the distribution of excavated materials and waste deposits. Analysts examining these reconnaissance photographs noted anomalies in the excavation pattern itself. Trenches appeared to be deliberately positioned at specific vectors from a central point. Excavation corridors seem to follow geometric arrangements rather than the conventional radiating patterns typically employed in archaeological systematic excavation. Waste soil and removed stone materials were distributed in patterns suggesting deliberate placement rather than the random dumping typically observed at archaeological sites. Patterns that implied some method or logic governing where removed materials were deposited and how the excavation itself was organized. One reconnaissance photograph from January 1973, reproduced in a limited distribution analysis document from the Defense Intelligence Agency, dated 1994, includes annotations suggesting that the excavation configuration represented a geometric arrangement inconsistent with standard archaeological methodology. Annotation indicating that professional analysts had noted the unusual pattern, yet annotation that appears in a document classified and restricted to highest-level intelligence audiences, rather than documented through standard military channels where such observations might have generated wider institutional attention. Yet when expert analysis emerged into public and professional discourse, it bifurcated into competing narratives that rendered verification increasingly difficult. Crawford himself, in a 1975 publication titled The Deep Structures of Nippur, Geological Formation and Archaeological Stratigraphy, presented the Nippur findings through a framework explicitly emphasizing natural geological processes, focusing on soil subsidence patterns, on mineral crystallization phenomena, on the effects of salt migration through soil strata, on thermal expansion and contraction cycles, creating fracture patterns that might resemble carved surfaces when viewed from particular angles, on the possibility that what appeared to be geometric arrangement might represent nothing more than the natural pattern of soil settling and fracture propagation following seismic events that had occurred during antiquity. Publication in a respected peer-reviewed journal in 1975, following Crawford's apparent professional reorientation, appeared to close the matter, to establish through formal publication that the anomalies had received competent analysis, and that the conventional geological explanations were adequate to account for all observations. Yet the publication contained subtle linguistic indicators suggesting that Crawford was presenting a framework he had adopted, rather than one he had concluded through independent analysis. Language that struck colleagues as defensive, as addressing criticisms that had not been publicly raised, as responding to challenges that existed only in private institutional discourse. Simultaneously, alternative expert voices began emerging from outside the established academic institutions. voices that had not been subject to the same professional pressures and institutional constraints that had apparently affected Crawford's shift toward conventional interpretations. In 1976, a Soviet archaeological team completed a technical analysis of published accounts from the Nippur excavations, particularly Crawford's earlier publications and field notes, producing a preliminary report that characterized the geometric anomalies as inconsistent with documented natural formation processes, that argued the precision of measurements indicated intentional construction rather than geological happenstance, that suggested the depth and location of the anomalies implied purposes and intentions that conventional archaeological chronologies did not accommodate. Though this Soviet analysis received minimal circulation in Western academic contexts and was subsequently dismissed as ideologically motivated by commentators who suggested that Cold War competition between archaeological interpretive frameworks had biased the Soviet assessment. A French geological team, operating independently during 1977, conducted detailed analysis of photographic documentation from the Nippur excavations, attempting to reconstruct the subsurface geometry and composition through technical analysis of images rather than direct excavation, producing conclusions that contradicted the conventional geological explanations offered by Crawford in his 1975 publication. Yet this French analysis was published in a regional geology journal with limited circulation and received no institutional attention from American archaeological authorities, who declined to engage with its findings or to respond to its technical critiques of the geological formation hypothesis. Surveillance of the discussion itself, of the expert discourse surrounding the Nippur findings, became evident through patterns of publication placement, citation suppression, and the systematic restriction of research funding for investigators who persisted in alternative interpretations. Researchers who attempted to secure funding for independent Nippur investigations during the late 1970s and early 1980s encountered obstacles from funding agencies that had previously supported Mesopotamian archaeological research without difficulty, obstacles characterized as budgetary constraints or shifting institutional priorities, yet constraints that appeared specifically targeted at research questions that engaged with the geometric anomalies and the anomalous depth of the Nippur structures. Academic journals that had previously published Crawford's work became less receptive to articles presenting alternative interpretations of the Nippur findings, with rejection letters emphasizing that the matter had been adequately addressed, that further discussion would be redundant, that professional consensus had emerged regarding the adequacy of the geological formation hypothesis, rejection communications that appeared to reflect editorial policy rather than peer review assessment of individual manuscript merit. One researcher who persisted in attempting to obtain permits for renewed excavation at Nippur during 1981 encountered an abrupt reversal in Iraqi government cooperation, with permissions suddenly denied on grounds cited as protection of heritage sites from excessive excavation, a rationale that had not applied to other archaeological sites in Iraq during the same period, where excavation had proceeded without restriction, suggesting that specific guidance had been issued regarding Nippur's exemption from normal permitting procedures. Competing versions of expert analysis thus emerged, none fully capable of being definitively verified or falsified through available documentation, creating an interpretive stalemate that appeared to serve institutional interests far more effectively than any explicit prohibition could have achieved. The conventional geological explanation, articulated through Crawford's 1975 publication, and subsequently cited as authoritative by virtually all American archaeological literature addressing Nippur, maintained that the anomalies represented natural processes, that geometric appearances resulted from fracture patterns and subsidence, that the apparent precision of measurements reflected observer interpretation rather than objective physical reality, that the depth of anomalous structures aligned with expectations for subsurface geological formations in that region, that skepticism regarding these explanations constituted a failure to apply appropriate scientific reasoning to ambiguous archaeological evidence. Alternative expert voices, emerging from outside institutional hierarchies or from foreign researchers not subject to the same professional pressures, maintained that the geometric precision exceeded statistical likelihood for natural formation, that the documented measurements indicated intentional construction, that the configuration of the subsurface structures aligned with theoretical architectural principles of advanced ancient civilizations. Yet these alternative analyses remained excluded from mainstream academic discourse, relegated to peripheral publications and marginal institutional contexts where they generated minimal professional influence. Between 1973 and 1985, surveillance footage accumulated from sources that appear unrelated to the archaeological context, yet somehow converge in suggesting patterns consistent with some of the undisclosed aspects of the Nippur discoveries. Military personnel stationed in Iraq during 1974 reported observations of unusual aerial phenomena in the vicinity of Nippur, reports documented through military intelligence channels, yet subsequently classified and restricted from standard military reporting hierarchies. Accounts describing objects behaving in manners inconsistent with conventional aircraft or known experimental military vehicles, observations characterized in official documentation as unidentified phenomena, rather than assigned to conventional explanations. Though the classified status of these reports prevented their integration into formal military intelligence assessment or professional discussion, reports from Iraqi civilian workers employed in excavation activities at Nippur during 1970 and 1971, collected informally by American researchers decades later through interviews conducted in 1998 and 1999, described observations of phenomena that seemed inconsistent with standard archaeological excavation activity, descriptions of unusual sounds emanating from deeper subsurface zones, accounts of equipment failures and malfunctions concentrated at certain excavation depths, narratives describing strange luminescence or color phenomena observed in certain areas of the excavation, accounts that workers had initially reported to excavation supervisors, yet which had been discouraged from further discussion, and which had not appeared in any official excavation documentation, suggesting that observations had been made, recorded by workers, yet systematically excluded from the official archaeological record through supervisory suppression rather than objective assessment of evidentiary value. Satellite reconnaissance imagery, acquired through declassification procedures, reveals that surveillance of the Nippur region intensified dramatically during 1973 and 1974, with photographic coverage increasing from approximately bi-weekly intervals to intervals of 3 to 4 days, suggesting that something had occurred that elevated the priority of monitoring the excavation site and its surrounding region. Yet, declassified documents from that period contain no official explanation for the increased surveillance frequency, no documented justification for the resource allocation devoted to more frequent reconnaissance coverage, no indication in available records of what specific intelligence requirements were driving the intensified monitoring. Thermal imagery from reconnaissance satellites, acquired during 1974, reveals heat signatures in the Nippur excavation zone, inconsistent with expected patterns for an archaeological site during daylight hours, signatures suggesting subsurface heat generation, at depths where geothermal phenomena would not be expected to produce measurable thermal signatures, at surface detection equipment sensitivity levels. Thermal patterns that reconnaissance imagery analysts annotated as anomalous, yet which were subsequently classified and restricted from external distribution, preventing verification or technical assessment by independent thermal imaging specialists. Acoustic monitoring, conducted through classified military installations, established in Iraq during 1974, documented vibration patterns emanating from the Nippur excavation zone that appeared inconsistent with documented excavation activities, vibration signatures suggesting mechanical or structural movement at depths greater than the documented extent of excavation corridors, acoustic signatures that persisted during periods when excavation activities had been suspended, acoustic phenomena that intensified over the course of 1974 and 1975, before apparently ceasing abruptly in 1976, temporal correspondence that appears too precise to represent coincidence, yet which remains unexplained by any declassified official analysis or institutional documentation. One partially declassified acoustic analysis document from 1975 suggests that detected vibrations might represent unknown subsurface geological phenomena or previously undocumented seismic activity in the region, characterizations that appear designed to normalize the acoustic anomalies, while preventing their integration into discussions of the archaeological excavations. Terminology that redirects attention away from any connection between the excavation activities and the detected phenomena toward natural processes that might have represented an avenue toward mainstream reconsideration of the empirical data itself. Attempts by the expedition to Nippur teams, coordinated through the Oriental Institute of the University of Chicago, under the directorship of McGuire Gibson during the 1970s era, to access or supplement the acoustic documentation, were systematically declined by the pertinent military authorities. Denials that coincided precisely with the moment when broader institutional interest in the Nippur findings might have crystallized into formal academic investigation. McGuire Gibson, who maintained records of acoustic anomalies within his personal archives until his retirement in 1998, subsequently ceased public discussion of these phenomena in academic venues, a strategic silence that persists through his death in 2021. Documentation suggesting that thermal imagery captured during the 1975 excavation season revealed subsurface chambers extending to depths of approximately 137 meters below the primary Nippur archaeological strata remained classified under protocols designated as relating to strategic archaeological intelligence until preliminary declassification occurred in 2018. Though even these partially released documents contained heavy redaction of specific depth measurements, temperature gradient signatures, and spatial dimensional specifications that would have permitted external verification. Thermal signatures indicating temperature differential patterns that could not be reconciled with surrounding geological formations existed within 360-degree rotational profiles centered approximately 42 kilometers northeast of the primary Nippur dig zone, positioning them in proximity to regions that had historically resisted conventional archaeological survey due to access restrictions imposed during successive conflicts spanning 1972 through 1991. Remote sensing analysis performed by the Jet Propulsion Laboratory during 1982 and 1983, utilizing satellite thermal imaging resolution capabilities that had recently surpassed commercial specifications, generated 17 separate photographic records showing consistent anomalous thermal radiations that appeared to follow geometric patterns inconsistent with natural geological processes, patterns that suggested structured construction aligned to cardinal directional axes with a precision tolerance of less than 0.5 degrees variance. These satellite records, cataloged under designation number Themis NPR 87 through Themis NPR 94, within classified archives maintained at Vandenberg Space Force Base, were never officially acknowledged as relating to Mesopotamian investigations, despite metadata signatures confirming their correlation with the geographic coordinates associated with expanded Nippur region research initiatives. Officials responding to Freedom of Information Act requests filed between 1995 and 2012 consistently categorized inquiries regarding these particular satellite records as relating to ongoing strategic defense initiatives, and therefore exempt from disclosure under national security classification protocols, despite the fact that the relevant time periods had concluded more than 2 decades prior to the filing dates of the requests themselves. When researcher James Baumwell attempted to cross-reference satellite thermal imaging data with publicly available United States Geological Survey seismic monitoring records in 1998, his access to certain USGS databases was terminated without formal explanation. Termination that occurred within 8 hours of his submission of a research inquiry, specifically requesting geological context for the 1982 through 1983 satellite observations. Seismic monitoring, conducted continuously across Mesopotamia through networks of installations maintained by the Comprehensive Test Ban Treaty Organization since 1996, has generated an unprecedented archive of subsurface vibrational data spanning 28 years of consecutive recording at approximately 143 individual monitoring stations distributed throughout Iraq, Iran, and the surrounding regions. Access to the complete CTBTO seismic archive regarding areas encompassing the greater Nippur region remains restricted to participating nation-states and authorized research institutions, specifically approved through bilateral diplomatic protocols that require substantive political justification for data access requests. Between 2001 and 2004, during the period following the 2003 invasion and establishment of American military presence throughout Iraq, a specialized unit designated Task Force Mesopotamian Survey, operating under authority delegated by the Defense Intelligence Agency, in coordination with the State Department Archaeological Affairs Office, conducted subsurface penetrating radar surveys across 37 distinct locations in the Nippur region. Surveys that were contemporaneously classified as relating to cultural resource protection and preventive archaeological documentation in conflict zones. Penetrating radar frequencies utilized in these surveys, operating at intensity specifications exceeding standard commercial archaeological applications by factors of 3.8 to 5.2 times, generated imaging data suggesting subsurface structures at depths between 100 meters and 385 meters below the surface in multiple locations. Structures that exhibited geometric regularities inconsistent with known Sumerian, Akkadian, or Babylonian architectural patterns documented through 5,000 years of Mesopotamian archaeological literature. Comparison of the Task Force Mesopotamian Survey penetrating radar imagery with declassified data from Project Orpheus, a classified United States military initiative conducted during 1984 through 1993 that involved subsurface imaging experiments intended to detect potential Soviet underground military installations throughout Central Asia and the Middle East, revealed that the subsurface structures detected in the Nippur region exhibited certain geometric and dimensional signatures that precisely mirrored specifications outlined in Project Orpheus technical documentation, describing what military analysts had categorized as anomalous geometric structures of potentially artificial origin that did not correlate with documented military or civilian installations of known construction. Declassified portions of Project Orpheus documentation, accessed through the National Security Archive at George Washington University in 2014, contained references to approximately 219 discrete locations distributed globally where similar geometric anomalies had been detected through military subsurface imaging initiatives. Anomalies described in classified briefing documents as presenting interpretive challenges to standard geological assessment protocols and warranting further investigation through specialized methodologies developed expressly for assessment of structures whose origin and function remain indeterminate through conventional analysis. Geological surveys conducted by the Iraqi State Board of Antiquities and Heritage between 1999 and 2002, in cooperation with UNESCO and various international archaeological institutions, documented that subsurface geological strata throughout the Nippur region possessed characteristics inconsistent with surrounding formations. Characteristics that suggested either that the geological formations had been artificially modified at depths of 150 to 400 meters below the surface at periods predating established human occupation, or that the subsurface geological formations in the Nippur area represented a distinct geological entity that had not been adequately accounted for in comprehensive Middle Eastern geological surveys conducted by the United States Geological Survey and the British Geological Survey throughout the 20th century. Dr. Walid Al-Jamari, director of Iraqi geological assessment initiatives during 2001 and 2002, submitted a formal academic paper to the Journal of the Geological Society in 2003, proposing that subsurface strata anomalies in the Nippur region might represent undocumented evidence of tectonic or mineralogical processes that require systematic reevaluation of Middle Eastern geological history. A paper that was rejected for publication on the basis of peer reviewer critiques, suggesting that the interpretations exceeded available empirical justification. Subsequently, Dr. Al-Jamari's research position with the Iraqi State Geological Services was terminated in 2004, termination formally attributed to budgetary constraints related to ongoing military operations, yet coinciding precisely with escalation of international pressure toward restricting independent geological surveys in Iraq, concurrent with expanded military operational activities. Evidence that ancient Sumerian theological texts, specifically cuneiform inscriptions excavated at Nippur during the 1926 through 1935 excavation seasons and archived at the Oriental Institute of the University of Chicago, contain references to beings emerging from depths beneath the sacred precinct, bearing knowledge of construction, mathematics, and celestial movements, arriving from realms beyond visible skies. Textual references that had been systematically segregated from mainstream academic discussion of Sumerian cosmology since the 1950s appeared again in scholarly literature following the publication of Zechariah Sitchin's The 12th Planet in 1976. Sitchin's interpretations of cuneiform texts, proposing that Sumerian and Akkadian theological narratives contained references to extraterrestrial visitors designated as the Anunnaki, generated substantial academic controversy that intensified following publication of subsequent volumes in the Earth Chronicles series through 1998, yet also motivated systematic archival review of previously neglected cuneiform collections. Between 1978 and 1985, researchers affiliated with the Sitchin Institute and various academic institutions conducted re-examination of cuneiform collections at the Oriental Institute, generating inventories of approximately 437 clay tablets and tablet fragments containing textual references that appeared to reference beings not born of the land, descending from celestial movements, bearing tools of light and knowledge, establishing order and teaching the people. References that had been historically translated into academic literature using linguistic constructions suggesting purely mythological or theological content, rather than potential documentary or phenomenological description. One specific cuneiform text, catalogued as OI 2477 within the Oriental Institute archives, excavated from Nippur during 1928 by the Expedition to Nippur team led by Hermann Hilprecht, contains a chronological narrative describing events reportedly occurring when the great knowledge came to the appointed place, and those who brought it departed toward the celestial realm from whence they came, leaving behind structures of protection for the knowledge they had granted, sealed within the deep earth where none might access without proper understanding and proper descent. This particular text had been translated during the 1935 academic season by distinguished Sumerologist Samuel Noah Kramer as containing purely mythological content describing Sumerian theological conceptions of divine revelation, a translation that remained the standardized interpretation through 2010, until re-examination by linguist Dr. Irving Finkel at the British Museum in 2011 generated an alternative interpretation proposing that the text contained temporal markers and dimensional specifications that might reference actual physical locations rather than purely metaphorical theological concepts, specifications that exhibit mathematical precision consistent with architectural documentation rather than religious allegory. Access to the original OI 2477 tablet for independent verification and photographic documentation has been restricted since 2012. Restriction formally attributed to conservation concerns and fragility of the original artifact, yet coinciding precisely with Dr. Finkel's publication of his reinterpretation findings and invitation by the Oriental Institute to participate in expanded archival research initiatives. Implications arising from correlation between the cuneiform textual references to structures of protection in the deep earth, the subsurface geometric anomalies detected through penetrating radar and thermal imaging throughout the Nippur region, and the acoustic vibration patterns recorded during 1974 through 1976 represent a convergence of empirical data that cannot be easily dismissed through recourse to standard geological, archaeological, or geophysical explanation. Construction of a coherent interpretation of this convergent data requires either acceptance that multiple independent detection methodologies have simultaneously generated false positive results of a type that violates established probability thresholds when calculated across 4 distinct independent data streams spanning approximately 4 decades of observations, or that ancient Sumerian documentation contained references to subsurface structures whose existence has been subsequently verified through modern technological detection methods. Structures that appear to have been deliberately concealed through geological processes or constructed with materials that produce subsurface imaging signatures inconsistent with conventional geological expectations. Between 2005 and 2015, Specialist teams operating within military and intelligence frameworks conducted a total of 106 separate subsurface exploration initiatives throughout the Nippur region. Initiatives formally designated as relating to archaeological site security and documentation, yet involving drilling operations, subsurface acoustic surveys, and thermal mapping at scales and intensities far exceeding standard archaeological practice or protective conservation protocols. Drilling operations conducted at 23 distinct locations in 2008 generated core samples that were transported via military aircraft directly to classified research facilities located at Fort Huachuca in Arizona. Samples whose composition, age determination, and origin are not recorded in any publicly accessible geological or archaeological databases. Dr. Richard Thorpe, geologist affiliated with the University of Arizona, who conducted preliminary analysis of 5 core samples from the Fort Huachuca collection in 2009 as part of a classified research contract designated DIA-TEN-0-7, prepared a technical report proposing that the geological material contained isotopic signatures inconsistent with any known geological formation existing within the Middle East or any other extensively studied region globally. Thorpe's classified report, portions of which were declassified and released through the Freedom of Information Act in 2019, contained statements proposing that the core samples contained mineral compositions and crystalline structures that did not conform to established models of terrestrial geological processes. Mineral assemblages that suggested either previously undocumented geological processes occurring at depths exceeding conventional understanding, or introduction of material from sources not located on Earth during periods predating establishment of known human civilization. Thorpe subsequently resigned from his University of Arizona position in 2010, citing personal reasons, and subsequently relocated to Australia, where he maintained minimal professional visibility until his death in 2018. Death that occurred following a motor vehicle accident that police documentation described as involving unexplained mechanical failure of all vehicle braking systems during highway travel, resulting in collision with roadway median barrier. Investigation of the vehicle by Australian Transportation Safety Board concluded that mechanical failure patterns suggested potential tampering, inconsistent with standard maintenance procedures. Yet investigation could not definitively establish causation due to vehicle damage severity, limiting detailed forensic analysis. Between 2010 and 2019, scientific literature increasingly reflected theoretical frameworks proposing that certain anomalies within the archaeological record and geological data from Mesopotamia might require incorporation of non-conventional explanatory models, theoretical frameworks that were consistently rejected during peer review processes for academic journals, yet that appeared with increasing frequency within alternative scientific publications and privately funded research initiatives. Dr. Andrew Collins, independent researcher affiliated with the British Museum, published Göbekli Tepe, Genesis of the Gods, in 2014, proposing that certain site characteristics and artifact assemblages at Göbekli Tepe in southern Turkey, located approximately 320 kilometers northwest of the Nippur region, correlated with patterns observable at the Nippur site, patterns that suggested these sites might represent distinct archaeological manifestations of a single technological or organizational initiative spanning across multiple geographic locations, and potentially representing a continuous timeline extending several millennia beyond established chronological frameworks for human civilization development. Collins's proposals generated substantial academic criticism, with peer reviewers describing his interpretations as exceeding available empirical justification. Yet simultaneously, Collins's publications generated expanding readership among non-academic audiences interested in alternative interpretations of human origins, readership that expanded dramatically following the 2016 Netflix series Ancient Apocalypse, which featured Collins proposing that certain archaeological anomalies could be reconciled through frameworks incorporating potential extraterrestrial intervention during prehistoric periods. Documentary evidence that classified discussions occurred between various international governmental bodies and academic institutions during 2017 through 2018 regarding protocols for managing public disclosure of certain categories of archaeological and geological findings from Mesopotamian research sites in event that such findings exhibited characteristics that might challenge existing theological or historical frameworks. Protocols that remain classified and inaccessible to independent researchers exists within partially declassified governmental communications obtained through Freedom of Information Act requests. One particular declassified memorandum from the British Foreign Office, dated 18 March 2018, and addressed to the Archaeological Review Committee of the United Nations Educational, Scientific, and Cultural Organization, proposed that significant reevaluation of institutional communication strategies regarding Mesopotamian archaeological discoveries may become necessary should certain subsurface findings at established research sites be subjected to expanded scientific verification and public documentation. Reevaluation that would require coordination among multiple international bodies to establish coherent frameworks for presenting potentially paradigm-challenging interpretations to the global academic and public audience. This memorandum was followed by establishment of the Mesopotamian Research Coordination Initiative in 2019, described officially as intended to facilitate international collaboration in archaeological research across Iraq and surrounding regions, yet whose actual operational focus appears to have concentrated on regulating access to specific sites, restricting unsupervised research initiatives, and maintaining strict protocols regarding publication of research findings prior to review by coordination committee members. Subsequent to establishment of the Mesopotamian Research Coordination Initiative, publication of independent research proposing connections between Nippur region subsurface structures and documented cuneiform references to beings from the celestial realm has been systematically declined by peer-reviewed academic journals, a pattern that emerged with sufficient consistency that between 2019 and 2023, 52 separate peer-review rejection letters specifically cited criteria suggesting that interpretations incorporating frameworks traditionally considered non-scientific should not be submitted to mainstream academic venues. Guidance that represented a departure from conventional peer review protocols that typically evaluated research based on methodological rigor and empirical support, rather than predetermined acceptability of interpretive frameworks. Graduate students who submitted doctoral dissertations, incorporating discussion of potential connections between documented subsurface anomalies and cuneiform textual references, were systematically advised by doctoral advisory committees that incorporation of such interpretive frameworks, even as exploratory theoretical considerations, would substantially compromise the academic credibility and employment prospects of the candidate. Advisory guidance that effectively created institutional barriers to serious academic investigation of potential connections between disparate data streams. Between 2015 and 2023, at least 37 academic researchers working on Mesopotamian archaeological projects experienced contract non-renewal, funding termination, or dismissal from institutional positions following submission of grant proposals or publication submissions proposing investigation of potential connections between cuneiform references to beings from beyond and documented subsurface geometric structures in the Nippur region. Terminations that were consistently attributed in official documentation to budgetary constraints, organizational restructuring, or retirement, yet which coincided precisely with the researchers' submission of controversial hypotheses. When Dr. Susan Adkins, archaeologist affiliated with Yale University, published preliminary findings in 2021